What is up? Daniel here with the Virtual Robotics Studio, and now it is time to actually program this robot and get it moving. So we're going to get started with that. Our goal for today is to do what we call Teleop programming so that you can use the Gamepads to drive the robot around. That's going to be a good place to start because you can function test the whole robot that way. We'll go through and do one motor at a time and make sure they all work. And then, of course, we will have to come back probably in another video where we'll work on the autonomous mode programming. So the first 15 seconds of a match is autonomous mode. Your robot can start with the game piece. If you score the game piece, you actually get a bonus point. So it's worth 6 points if you score high instead of 5. And then you get some points if you can drive across a line, and more points if you can balance the charge station. So we'll work on that later, but after the first 15 seconds, we have another 2 minutes and 15 seconds of driver control mode or teleoperated, and that's what our focus is for today. So we're going to get started programming in just a second, but before we do, a special thanks to Argosy and Everybot. All right, as we get ready to start programming here, we're going to hopefully be able to do the wireless connection that we set up in the last video. If not, though, it never hurts to have, a 25-foot or so or longer Ethernet cable because it usually works with the Ethernet cable. It's a little bit more consistent than the wireless. Also, I think get some of these in the rookie kit of parts, but if not, you're going to need 2 gamepads or 2 joysticks that we're going to use to control it. The way that most FRC teams control their robot is they'll have one driver that kind of drives the base around the drivetrain to move the robot around the field, and then they'll have a second driver whose job it is to control everything else. So in the case of our robot here, that would be extending and retracting the arm, as well as sucking in the cube, the cone, or spitting them out. So working that intake that we've got there. All right, on your computer, though, that is the other thing we need. And we are going to now run. We have this 2023 WPI-lib VS code, and that's what we want to run. And this will be our first time running it. So we'll see what pops up here. First thing is you can get the look you want. You can have dark themed or light themed. I usually pick the dark theme, so that's what I'm going to go with, but you can pick whatever you want. And then we're just going to say done. All right. Now, to start a new project, you would think you go File and say, hey, new whatever. That is not what we're going to do. Instead, on the right-hand side, there is this W symbol. That is the WPI-lib symbol. And that will open the WPI-lib command palette. And so that's what we need to do. We're going to click on that. And it gives us a whole list of things that we can do. And the first thing we want to do is we want to create a new project. So I think if I type new, there it is, create a new project. If you get any of the words right, it'll filter down for you. So you can type new, you can type create probably. And once that shows up, you can just click on it. And we are now on our Project Creator tab. So the first thing we have to do, we're going to basically go through and select stuff for all of this. The first thing we're going to do is select a project type. And we are going to do a template. So the examples are good. I'm going to click on example for a second. There are a lot of different examples that you can look at if you want to try to do your own code and add your own code in. But we're not going to do that because we are going to be starting from scratch and building the program up as we go. So template. Then what language do you want to do? We're going to do Java. C++ is your other option here, but pick Java. And then what is the template that we actually want to use? And we're looking for timed robot, timed style. OK, next step is create a base folder. So we're going to select a new project folder. And what I like to do is I go to the desktop. I create a new folder. You can right-click to create a new folder or click the new folder button, I guess. And this is just going to be my 2023 FRC code folder. And then I might have different versions of the code that are going to show up here or whatever as we build through it. So I'm going to then select that folder and then just say select folder. So now all the code we make, all of these things are going to be saved into that folder. All the different projects that we make, we can just use that folder to save them in. And that is what the next one is. This is, hey, what do you want this project to be called? And so this is our 2023. And you can call it whatever you want. Oh, you can't put spaces here, though. So this is going to be 2023 FRC. And you could put your team number here or just code, whatever you want. like the underscore there. Again, this is a name for the project, so you can name it literally whatever you want. This could be your test program. This could be your final program. However you want to designate it, it is good to have your name make sense. So when you're looking at all of the different programs that are on your computer, you'll know, OK, this is the one I want. If you do some changes to it, right, you could save that as a new version of code and say that new version is like, hey, updates after practicing or something like that. You could put a date on it. Dates are really good if you get into multiple versions. All right, we'll create a new folder, yep. And then down here, you want to put your team number in. So I'm going to stick with 469 because that is the team number I've been using all along. But this should be whatever your team number is. And I think you can check or not check this box. I don't think we're really worried about using it. So I guess I'll leave it unchecked. And then we are going to generate a project. Project successfully created. Would you like to open the folder? You can say yes in a new window or no. We're going to say yes in a new window. And it's going to pop up a whole new window here. And now here it's asking, like, do you trust the authors or of the files in this folder? Well, technically, yes, because we're going to be the authors of the files that end up in this folder. So just check the box and say, yes, I trust the authors. All right. And it's doing a quick little build here for us as it opens everything up. And while it's doing that, you can actually, this other window, we don't need it anymore. You can close that window. So this new window is everything we're dealing with. All right, and there is a note down here, right? It's doing this thing. It's building everything. It's going through the whole project. It says subsequent builds will be faster. So the first time it has to go through all this, it's going to take a long time. And then it's going to get much, much faster after it kind of gets everything in place. All right, so all we can do is wait until this finishes. And mine is finished. OK, took 39 seconds, in fact. All right. Now, just to take a little tour around what we're looking at. So anytime we want to do a WPI-lib command, we're going to click on that W and type stuff in. You can go split screen or not split screen. If you want to look at two files at the same time, you can use that split screen to do that. And then you can always hit the X to make one go away. We've got our 3 dots here. And these 3 dots is one of the ways in which we are going to be able to actually download our robot code. So every time we need to send code to the robot, we're going to build it, and then we're going to deploy it. You can also get to that, I think, by right-clicking on build.gradle over here and choosing build robot code and deploy robot code. Over here, this is a list of kind of all the files that we are working with. And there's a lot of files here, but here's the good news. We can look in here, look at all this stuff. The good news is we don't care about anything but in SRC. So in SRC, that's not completely true. We do care about vendor deps as well. But in SRC, we have deploy and we have Java. If you open up Java, there are 2 files. And if I click on main.java, this is what the file is. We care about this file a little bit, but we're never actually going to edit it. So I guess technically we don't care about it. Then robot.java, this is it. This is the one file where all of the default code is. This is the template code that we put in there. And this is where we're going to add all our code. All our code goes in this one file. That's it. Robot.java. We don't care about anything else, except the little bit that we do. All right. Then in vendor dependencies, vendor deps, we right now have our WPI-lib commands, but we have to add a couple of other vendor stuff in here. We use the REV stuff for our Spark Maxes, and we're going to be using the Victor stuff, which is the Phoenix framework, I believe, for our Victor SPXs. So let's add those first before we get too far along here. And to do that, we're going to click on the W. Oh, also, of course, you have file. You can save and save as to make a copy and all of that normal stuff. And I don't think I really go into these other menus very often. So there are settings you can do. You can change the font. You can probably change the colors. All that stuff exists in there. I'm not going to bother doing any of it. All right, click on the W. And what we need to do is we need to add in another vendor library. So we could do vendor. There it is, manage vendor libraries. Click on manage vendor libraries. And now we have a list of options for how we want to manage our libraries. We can check for updates on the ones that we have. And we'll do that maybe once at the end. We can also install new libraries. Install new libraries offline means you have to go out, find the library, download it, and then install it. And then we can also install new libraries online. And this is the easiest way to do it. So we're going to choose Install New Libraries Online. And what it wants now is a URL to the library that we're dealing with. So if we open up our web browser, of course, I already put the link in, but we're going to go back to WPI Lib, and we're looking for third-party libraries. Now, you don't have to type this all out. We have included this link in the description below, so you can just click on that to get where you need to go. And in fact, we can also include the direct links to the libraries that we are going to be using. But if you scroll down in the libraries area here, these are all the different extra libraries that you might want. And the ones we're looking for is we need Phoenix. So we can use this Phoenix V5 is the first one. So if you copy that link right here, we can copy that. And then go back to Visual Studio or VS Code, and we're going to paste that in. So that is basically, a website. It's a web link. And all you got to do is hit enter. And it's going to say, it is recommended to run a build afterwards. Would you like to run a build now? Say yes. It's going to take a second. Again, this is a subsequent build, so it should be faster, hopefully, than the 39 seconds it took the first time. But you can see over here, we now have phoenix.json in our vendor deps. Oh, 8 seconds is much faster. All right. So that is one of the two things. The Phoenix stuff, right? We use Phoenix Tuner. That is for the cross-the-road electronic stuff, the Victor SPX. And then we are going to do the same thing again. So right here, I'm going to click. I'm going to manage vendor libraries. It remembers my recently used ones. If not, type vendor. And we are going to install a new library online. And I'm going to go back over here, and I'm going to scroll down a little bit and find REV Robotics, the REVLib. REVLib. So I'm going to copy that one and go back to VS Code, paste that one in, hit enter. Again, we added a new library. We should build. Sure, let's build. And it looks good. All right. Ooh, only 5 seconds that time. We're improving. OK. So now we have Phoenix, REVLib, and WPI Lib. So that's all we need. As long as you have those there, now we don't care about vendor deps anymore. Again, we did say, though, we can go into Manage Vendor Libraries. Remember, we can check for updates online. Go ahead and click Check for Updates online. Now, there should be no updates available because, of course, we just went out and got them. But that's what you would do if it sounds like there are some issues and updates got released during the season. Chances of that are not super high that they'll be critical where you have to do that. OK, we're going to go through the code that is here and try to explain the things that are here. And then we'll start writing our own code. We're going to end up changing some stuff. We'll end up deleting some stuff that's here. We'll end up adding a lot. So the first thing is at the very beginning, basically we say, hey, this is an FRC robot. That's what this package FRC robot is. And that means we can use things that are available to the FRC robot class. That's what they're called. Then on this import, these are basically all of the bits of the library that we're actually going to be using in the code. And the idea is there are a whole lot of things included in WPI Lib. There are a whole bunch of things included in our other two, right? Our Phoenix and our REVLib. So we don't want all of them. And if it loaded all of that into our code all the time, it's just not necessary. So we're going to have to just pick and choose the specific things that we want to use. And that's what these import statements are doing. Timed robot is, of course, the type of robot we're making. And then we have these smart dashboard things. And the smart chooser actually will let us, or the sendable chooser, will let us actually pick our auto mode from the dashboard that came up. Remember when we ran the driver station? We had the driver station on the bottom and then that dashboard that popped up on the top, and that's how we're going to select our auto mode. Then as we scroll down, basically we are making a robot, which is a timed robot. So it's a class that extends another class, this timed robot class. But anyway, you don't have to worry too much about that. If you know Java, that's going to make sense to you. If you don't know Java, don't worry about it. What matters is we have this open parentheses here, or open curly brace, and then there is a closed curly brace all the way at the bottom here. And everything inside of this is part of that class, and everything inside of this is going to be stuff that will run when this code runs. And the first stuff here, what this is doing is anytime you see a private, that means that the thing we're creating is usable only inside of these curly braces, inside of this class. When you see static, static means it's not changing, right? So we can create a variable that is static, and it will never change. And that's what we're doing here. And what that means is we have, if we wanted to choose K default auto, it would show the text default. So these two lines of code right here, are basically creating a list of the different auto modes that we can choose from. We're not doing auto mode today, so we're basically going to skip over them now. The next line of code is then using a variable. So a variable is the same thing as in math. We're using a word, which in this case is m_auto selected, to store a value in it. And in this case, we'll store whether we're doing my auto or default auto. But on the robot, we're actually going to have like a cone auto, a cube auto, a drive only auto, a do nothing auto. And that's what we're going to be selecting for. But that's all we're doing is we're saving that value in here. So later we can say, hey, which auto did you want to use? And then the sendable chooser, this is basically loading that dashboard with the information that we want of our different possible auto modes. So again, we're gloss over the rest of that. We don't care because we're not doing auto modes right now. Same thing here. When robot init happens, so you can see there is this public void robot init. So this happens one time, and it will happen when the robot first turns on. So anything inside this curly brace and this curly brace is part of robot init, and it happens once when the robot boots up. Again, this is all autonomous mode stuff right now, so we're going to skip over it. Then the next one here is robot periodic. And there are usually notes. So actually, see how the two curly braces are next to each other here? That means if we wanted to add any code to robot periodic, we would have to actually go in between them and hit enter. Now we have a place where we can actually add that code, which we might do, but we're not doing yet. So I guess I'll undo what I did. Now, it tells us right here what's happening in robot periodic. This function is called every 20 milliseconds, no matter the mode. So if you want something that runs constantly all the time, every 20 milliseconds, you put it in robot periodic. All right, scrolling down, we have autonomous init. This gets run one time before autonomous mode starts. So if you needed to zero anything out or get things ready for autonomous mode, we're going to put it in here. Next one is autonomous periodic. So this gets called over and over again while we are in autonomous mode. So the first 15 seconds of the match. So this is where we're obviously going to write our actual autonomous modes. Don't care because we're not doing autonomous mode yet. Then down here we have Teleop init. In Teleop init, this runs one time before Teleop starts. So anything we want to change from autonomous mode for Teleop mode, we're going to set up in here. Then we have Teleop periodic. This is the part that runs over and over again while we are in teleoperated mode or driver control mode. This is where most of our code today is going to end up, in between those two curly braces. All right, there are other states that the robot can be in. It can actually be in a disabled state. You could have code that runs when the robot is disabled only. You can have code that runs the first time the robot is disabled, once at the beginning, over and over in disabled. You can also have code that runs in test. Right? I think we looked in the last video, and I was like, I don't know what test mode is. I don't really use test mode. Well, it is here. You could do code that runs in test init and test periodic as well. And then you can actually run your code as a simulation as well on the computer. We're not going to get into that, but there is simulation init and simulation periodic here as well. All right, and that's it. That's the whole code. We've been through everything, and now you are experts and know how to make this robot work. So go all the way back up to the top. Let's start with our imports. We definitely have to import some more things. So the first thing that we have to do is we have to import. So I'm going to type import. Now, here's something that happens as we type commands in. You will notice that this box is popping up here, and that is our autocomplete box. So when you see something popping up, you can click on it with the mouse to select it, or you can hit tab. I think you can hit enter as well to use autocomplete. Now, I recommend doing this as much as possible because Java is a syntactical language, right? We have to type the stuff in, and it has to match. It has to be typed correctly. If you have a typo, code's not going to work. If I typed in import, but instead of typing import, I typed in import, guess what? It's not the same. See how that doesn't turn blue? That means it does not recognize that as a command. It is not the command that we expect. So it's case sensitive, so you make sure you got to get the right cases as well. All right, so we're going to import, and what we need is the ability to use joysticks or gamepads. So that's going to be edu, and you can do tab, dot, and then it does a dot star. It's going to be WPI dot first dot WPI lib. It's basically we're copying the line above it, dot, and in this case, we are going to add a joystick with a capital J. And I hit tab, and it fixes it. And I think even if I type the joystick with a lowercase j, check this out, it still sees it on the autocomplete, so when I hit tab or enter, it fixes the case for me. That's why the tab completing is really, really good at avoiding typos, which will, of course, keep your code from running. Now, I don't really understand this. It just keeps adding these semicolons. In Java, most lines of code, when we get to the end of the line of code, we put a semicolon in. And the idea is the semicolon tells the compiler that, it tells the robot basically that that is the end of that command. So having 3 semicolons here actually doesn't hurt anything. It's actually the same thing as having a blank line and another blank line, which, okay, that's fine. It will basically get ignored when we compile, when we build the code. But I'm going to delete them because it doesn't look clean. And I don't know why it adds them when we do the tab completes, but it's still worth it to tab complete and then delete the stuff than to not tab complete and mistype something. Okay, then you can see we got some squiggly lines here. So I don't know, is that yellow? That yellow squiggly line is telling us that this thing that we created, that we imported, is never being used. And I think if we, does that do it? Okay, yeah, if we click on this, it says, hey, removed all unused imports. We don't want to do that though, right? Like it's unused right now, but that's because we're not done writing our code. So if you see the yellow squigglies, not a big deal. Now, if you see the red squiggly, that means something is wrong with that line of code and you need to figure out what it is. In this case, of course, I misspelled joystick. All right, we have more imports though. We are not done importing. So that is everything we need, I think, from the WPI first.wpi lib. But remember, we brought in all of our Phoenix and all of our REVLib stuff. And so we need to import the bits of that we're going to use. Otherwise, why do we bother, bringing it into our code here? So another import. And this time, we are going to import the, let's do the REV Robotics stuff. So we're going to do, com dot, and I'm going to do REV Robotics dot. And then in this case, it is going to be can Spark Max. So I guess if you get to can SP, even if I didn't bother capitalizing it, but can has to be capitalized, as does the S in Spark and the M in Max. Dot. Wait, no dot. We're done. That's it. That's that whole line. Okay, so this is going to let us use Spark Maxes. And then we have a couple of other things that we want to be able to do with our Spark Maxes. So we're going to do another import. And again, you could copy all of this. Actually, you could copy this whole line, I think, because we're going to do the whole thing again. So that's fine if you want to. com.revrobotics.can Spark Max dot. This time we're adding the dot. And the other thing we're going to need is idle mode. And it gave me 2 semicolons, so I'm going to delete one. Idle mode is, there are 2 options that we have when the robot is driving. We can have it in coast mode or brake mode. That's for any motor that is controlled by, right now, a Spark Max controller. Coast mode kind of means what you think it means. If we're driving forward and we let go of the joysticks, the wheels will just be free to coast forward. So we'll continue on kind of rolling forward until it hits. Brake mode does what you would think as well. Brake mode will actually sort of apply brakes to the robot, so you're going to slow down much faster. The way brake mode works is actually all motors are electric generators. An electric generator and a DC motor are almost the same thing. And the idea is if you spin the wheels, you're actually spinning the motors in the robot, right? The transmission. And when those motors spin, they're actually creating electricity. And you can actually see this if you, while your robot is off with no battery plugged in, if you push it across the ground and get those wheels spinning, if you do it fast enough, you will be able to actually get things on your robot to light up and turn on. But what you can do is, if you take that electricity that's being generated, right, and flip it around and pass it back to the motor, we're basically using the electricity that the motor generated to power the motor in the opposite direction that it's trying to spin, and that's how we brake it. It's called dynamic braking, and that's what brake mode is. And we want to be able to turn brake mode off when we're driving around normally, because if you are driving fast and you brake really hard, your robot is going to have a tendency to start to tip forward or start to tip backwards. So when you're driving around normally, usually you want it to be in coast mode, but we have that ramp that you have to climb up and park on at the end, the charge station. So when you're parked on that, if it's on an angle and the match ends, if you're on brake mode, you might actually be able to hold your position long enough to get the points for being up there. Anyway, so that's why we need to add that. We're going to add one more thing. Import com.revrobotics. It's another can Spark thing. And this time, we are going to add, can spark, we got to keep going. Can spark max. This time we want this low level one. So when there's multiple things, but you can see the one you want, you can actually hit the down arrow to select it and then hit tab, or you can pick it with your mouse. And that's what we want. We need can spark max low level dot. And we're going to do motor type. And we kind of set the motor types when we set up our devices. So I think we could get away without having this, but I feel more comfortable explicitly saying whether it's a brushed or brushless motor when we go in here. All right. That is a double semicolon again, so I'm going to get rid of it just because it looks ugly, not because it's a big deal. And I'm also leaving some spaces, blank spaces. When I skip a line of code or a line, it does not change the program at all. So when you see me leaving spaces, it's because these are all the imports from WPI Lib. These are all the imports from REV Robotics, and we're done with that. So now I skipped another line so that we can start to import our CTRE stuff. And so that's going to be com.ctre.phoenix, because that's what they call their software stuff, Phoenix dot. And it's going to be motor control dot, and it's going to be control mode. There we go. Delete a couple of our extra semicolons. And I'm not going to go through everything again. Basically, everything we're adding here is the equivalent to the three things we already talked about, but it is for the Victor instead, the across-the-road electronics speed controller instead of the Rev one. Let's do another import, com.ctre.phoenix. Eventually, I'll be able to type Phoenix correctly. All right, dot. And this one is going to be another motor controller, or motor control dot. And this is neutral mode. Neutral mode is our idle mode, right? Same thing. And one more, import com.ctre.phoenix dot motor control dot. Oh, I did not tab that one, so it was not quite right. Dot can dot. And now it is the Victor SPX, because that is the actual device that we need to use. So we need to bring that in, just like we had the can spark max up here. OK, we have got all our imports in. The next thing we're going to do now is we are going to move down in our code. We're going to go inside of this public class robot extends time to robot. We're going to go past the first bit, though, that's here. And we're going to start adding some of our own stuff. So you need to be above robot init. We want this to just be as part of the main class robot stuff, not in any of these other classes like robot init or any of the other things we're running. And again, I'm just going to add some spaces here because this is new stuff. So we have our old stuff that was here that we're going to use some of and we're going to replace some of. But I'm going to skip a line. And then in here, we need to add a bunch of things. So we imported the ability to use, for example, like a Spark Max. But in order to actually use the Spark Max in our code, we have to sort of declare it here. We have to say, hey, we're making a new one, and we're going to be able to use that. And so we're going to do can Spark Max. And you can see can Spark Max is the can Spark Max from right here. So that is, right? That is what we already did. And actually, yeah, then we're going to do a space. And now we get to name this particular Spark Max. We're going to have different instances of it, right? We need one Spark Max for each Spark Max on the robot. So we're going to have a left drive one. We're going to have a right drive one. We're going to have an arm one. And we're going to have a intake one. So we're going to have to create a variable for each of those. And you can name this variable whatever you want. All right, so the first one that we're going to choose is we have a Spark Max that controls the left drive. So let's call this drive left, and it's a Spark, so drive left Spark, right? Because we're also going to have a drive left Victor at some point here. All right, and you do a space. So that is the name of our Spark Max that we're creating here. We're going to say equals. You see that turns like the light blue. That is now our variable color. And then it is a new, and it is a new can Spark Max. So actually, it already knew I wanted a can Spark Max. So you can just tab, boom, we're good. And up here, the device ID. So all those can device IDs that we went through and set, this is where we put them. So then our program now knows, well, device ID was 1 for that one. So it knows device ID 1 was that left spark max. That's why we plugged into the left spark max and picked 1 on the REV, whatever software that we were using before. All right, and then for type, I don't want null. I'm going to delete that. This is where we tell it what kind of motor it is. So we're going to do motor type, and it's going to be .k brushed. So these are brushed motors. The brushless motors are the fancier ones that needed 3 wires. So that line is good. And guess what? We need another one. Again, you can type it all out. You could just maybe like copy all this, do a little paste. And we just have to change a couple things. The first thing is we can't have 2 things called drive left spark. This one would probably be our drive right spark. And you will notice I am doing lowercase to start and then capital every time it's a new word. That's called camel case. That's supposed to make it easier for you to read where the words are. If you prefer, you could do underscores in between them. We're going to use underscores for a slightly different reason later. But yeah, make sure you change it to right. And if it's capitalized up here, it has to be capitalized everywhere else we use it in the program. If it's not capitalized up here, it has to be not capitalized everywhere else in the program. All right, this is also a brushed motor, but it cannot be device ID 1 as well. It has to get changed to device ID 2. Right? We did spark on the left was 1, and spark max on the right was 2. So those lines are created. Now we have to do our 2 drive victors. So let's do those. It is going to be a Victor SPX. And now we get to choose the name for it. And the name is just going to be, like, keep the same format. Drive left. And this is going to be our Victor. Drive left Victor. And we do equals. And by the way, this space here, you don't need this space. Your program will work without that space. I'm going to add some extra spaces because I think it's easier to read. And I just want you to be able to follow what I'm doing. But in between new and can spark, that space you do need, right? Like, because otherwise it changes to a different word. OK. Equals, and this is going to be a new, and it is going to be a new Victor SPX. And for the Victor SPX, all it wants is device number. It doesn't have anything else that needs to be put in here. Like the Spark Max can do brushed motors and brushless motors. The Victor SPX is just brushless motors, and I believe our left one was number 3. So we always did left first, then right, which is a good rule of thumb because we read left to right, and as long as you remember that and always follow that rule, you should be able to remember the order things are. So that's a 3, and make sure you have a semicolon at the end of these lines. That one I think did not add a semicolon for me, so I added my own semicolon there. And then, guess what? We did the drive left Victor. We have to do the drive right Victor, so you can again copy this whole line of code or type it again, whatever you prefer. And all we have to do is change left to right and change device number 3 to device number 4. And it adds this device ID. You don't have to type that. I don't know if you noticed that, but it's kind of weird, right? Like when I delete this, it just goes to the number. But then when I leave the line or just let it sit there for a second, it pops that little device ID tag up. So if you've been typing that in yourself, I think, I don't think it actually works if you type it in yourself. Let me see. If I type device ID :1. OK, that does not work. So if you've been typing device ID, you're going to get a little red squiggly here. It's not going to work. Just put the number 1 and let it add the device ID for you. Same for all 4 of these. All right, now, the next thing we have to do, I'm going to add some spaces here, is we have to create, so we created specific CAN Spark Maxes and Victors for our drivetrain speed controllers. The other thing we need, we're going to just do the drive first. We're going to get the drive working, then we'll come back and start adding the other pieces. So the other thing we need to be able to drive is we need a gamepad or a joystick to be able to control it. If you remember, we also had that joystick class that we imported up here. There it is. Import .joystick. So down here, I'm going to do joystick, and I'll autocomplete. And we get to name the joystick, and just to keep stuff straight. This is not necessary. This is a name. You can name it whatever you want, almost without limit. But I'm going to do a J, a lowercase j, and then a capital drive, because this is or driver, because this is the joystick that's going to control the robots driving around the field. And lowercase j for joystick, that just keeps things separate, right? So if I just had drive here, for example, I have drive all over the place. And like, what drive is this? But having J drive or J driver, I'm going to stick with drive. I like drive better. Lets me know what this joystick is for. And that equals a new, and it equals a new joystick. And inside the joystick, it wants to know what port we are going to be plugging this joystick into. And basically, 0 is fine. We're going to have 2 joysticks eventually. So we'll put one on port 0, one on port 1. Those ports have nothing to do with the CAN IDs on the robot. Those have everything to do with when you plug them into your laptop, they will get assigned a number. And we can actually drag them around to put them in different places. So we're just going to use 0 and 1. And this does need a semicolon. Nope, not inside. 0, we need a semicolon at the end of this line. And that is perfect. All right, now we're going to start working our way down here. We're going to scroll down to, wow, where do we have to go? Do we need anything in Robot Init? We do want some stuff in Robot Init, I think. And what we're going to put in Robot Init is, so all of these motors have a forward and a backwards. And we have 2 motors in the same gearbox on the left side of the drive, and we have 2 motors in the same gearbox on the right side of the drive. Now, the nightmare scenario is, if one of those motors is trying to go forward and the other one is trying to go backwards, they're literally going to fight each other. They're going to stall. Stalling is when you're sending power to a motor, but it isn't actually turning. And when motors stall and they're trying really hard to spin, they're going to heat up. And if it does it for too long, the motors can actually burn. You'll see smoke. It's not great. Now, the drive motors, really durable. They can do this for a long period of time before bad things happen. But what we want to do is we want to be able to control the direction that they spin. When we say go forward to the robot, we want to make sure that each motor knows which direction forward is. And so inside Robot Init, remember, it starts with this open curly brace and ends with this closed curly brace. So I'm going to go underneath this smart dashboard.putData line. We are going to create some line of codes that will let us invert all of our motors. So if forward is ever backwards, we can use this invert to flip it around and make backwards forward. So we do that by basically typing the name of our speed controllers, or of the motors that we've created. And so that is drive left spark, for example. That's one of them. And then we're going to do a dot, and we're going to do set inverted. So if you do set in, you can hit tab. And right now, we're just going to type false, because we don't know. We don't know if it should be inverted. We don't know if it shouldn't be inverted. We have no idea. So we're just going to make it false. All right, and then we need to do the same thing for our drive right spark. So drive right spark dot set inverted. And we're going to do false again. And this one added the semicolons for me, so I'm not worried about that. And then we're going to do drive left Victor dot, and I think it is also set inverted. I think they have the same name here. There we go. But there's more options on this one, so I had to type more than set in. I had to get to invert. Set inverted, and right now it is going to be false. And then finally we have our drive right Victor dot set inverted. And again, it's going to be false. Now, there's a good chance that at least 2 of these are going to need to turn to true. If you think about it, on our robot, we have 2 motors that are facing to the left side. And if they're spinning forward, but we took that robot and put it instead on the right side, right, what was forward is now reverse. So there's a really good chance that 2 of the motors, probably 2 on the same side of the robot, are going to have to be inverted. But it's not crazy. I have seen sim motors that are wired backwards to each other, to where forwards on one, if you do the same voltage on one, it spins one way, and the other one would spin the other way, so that can happen too. So we just want to be extra, extra safe that we have all these set up, and we're going to come in and we're going to edit these once we know what needs to be inverted and what doesn't need to be inverted. All right, let's move on. So we are looking for Teleop init down here. So we have public void Teleop init. Remember I told you we have to be inside these 2 curly braces right here. So click your mouse in between them and hit enter. Now we can add code in Teleop init. Now, in Teleop init, the first thing we're going to do is we're going to make sure that our drive motors are set to coast. So in autonomous mode, one of the potential autonomous mode options is to drive up on the charge station and try to balance it. So you may work on that, in which case you might want brake mode in autonomous. Another thing too is, in autonomous mode, we're going to try to drive across a line, drive out of the community to get points. Well, after you're done driving, you do not want the robot to keep coasting. We don't want to crash into anything. So in autonomous mode, because we can control the speed, we can move slowly, we want brake mode so that our robot is more precisely placed. But once we get into Teleop, we don't want the brakes like hitting every time we stop and making our robot tippier than it needs to be. So in here, we are going to do drive, and it's going to be left spark. This time it's going to be a dot. And we are going to do set idle mode. And inside idle mode, inside these parentheses now, we're going to type idle mode dot k coast. And I'm going to throw a semicolon up. So what that means is now the left spark max, or drive left spark max motor and controller is going to be set to coast mode. Guess what? We've got to do the same thing for all three of our other drive controllers and motors. So let's switch this to right. And all we have to do here when we copy and paste is change the left to a right. Now, pay extra attention, right? If I type this wrong, if I forgot the capital R, we will get the red squiggly lines. So if you get the red squiggly lines, know that it is typed wrong because we're not auto-completing this one. Then another enter, and it is another drive. But this time, it's going to be our left Victor dot. And the command is slightly different. In this case, it's going to be called set neutral mode instead of set idle mode, which remember when we did the imports, we had the idle and the neutral, and it's all making sense now. All right, and the neutral mode is going to be neutral mode dot coast. There we go. And again, we could copy this one, and we'll paste it. And this time it is not the left Victor, but the right Victor. Right, make sure there's no squigglies, no errors there. Now we've successfully set everything up to be the right drive mode, so all coasting. And our next stop is Teleop periodic. So once again, find the two curly braces, get inside there, hit enter, and let's talk about what we actually want to do here. In Teleop periodic, we can actually start to control the motors. We can turn motors on and make them move. And the way you control a motor is, the line of code is basically you type the name of the thing, so like drive left spark, for example, dot, and then you throw a little set in there, dot set. And inside here, it's asking what speed do you want me to turn on at? And we can choose a number. The number 0 means turn on at 0 speed, don't move. That number can go all the way up to 1.0, which is full speed forward. We can do negative 1.0, which is full speed reverse. And then we can use any decimal in between. So if I wanted to go like 30% forward, I could do 0.3. If I wanted to do 75% backwards, we would do negative 0.75. And that's basically it. That's how we control the motors. And a value of 1 here, or 1.0, basically means take all the voltage that the battery is giving us and give as much of it as we can to the motor. Basically open up the taps. When we say send like half of that, really it can't actually say, well, you have 12 volts from the battery, so send half of the 12 volts to the motor. Actually what it does is it sends 12 volts, but it only sends 12 volts for half the time. So half the time you get 0 volts, half the time you get 12 volts. The average then is 6 volts, and you end up having your motor spinning about half speed. Okay, but if we were just going to type a number in here, as soon as I run the program, and as soon as we enable it, the robot is just going to start driving. And that's not what our goal is. Our goal is to use the Gamepad to control everything. So let's take kind of a closer look at the Gamepad here. I can pop up a picture of it on my computer. And we can talk about what the Gamepad has for us and what we can do with it. So on the Gamepad, there are these, we have the axes or the joysticks here, and we have the buttons. And on this Gamepad, of course, we have the ones that we can see, Y, B, X, and A. But there are also some more buttons hiding here, right? Like we have these side buttons. There are 2 side buttons. I think they're called left bumper, and left trigger, right trigger, hiding on the side. So there's 2 buttons on the sides here. Anyway, there are two types of inputs. Buttons are one type of input, and then axes are another. And buttons, like are, whatever, like these, like B and A and so on, they work in a very simple way. They're either pressed, true, or not pressed, false. So what we can say is, hey, if you press the button, that will be true, and we can do something with that. If you're not pressing the button, that's false, and we can just not do anything. That's not what we want for driving, though, right? Because we don't want to have one speed of driving. We don't want to be like, OK, I pressed the button, go full speed forward. That would work, but it would be very hard to actually maneuver your robot, aim for stuff, pick up things that you need to pick up, get it in the right spot to be able to drop the cone of the cube on the goal. So the other option that we have on here is the joysticks, and we call them axes. And axes because, like in math, you've got your two axes when you do, you got your x and your y axes. And if I look at the joysticks, there's two different joysticks here. So one of them, like over here, this is our left side. And then our other joystick, so this joystick is left, this one over here is right. And each joystick then has two different directions that it can move. So it can move up and down. And when this one moves up and down, this direction here on it is the y-axis, or the y direction for this joystick. And when we move left and right, that is our x-axis, or x direction. And here's the good news. The good news is this works really, really well for us. If we go all the way forward on the joystick and push it all the way forward, that gives us a value of 1. Actually, that's not true, because the joysticks, there's this weird thing in computer programming where all this started, and that is that the computers used to render the screen from the top of the screen, the first line of the screen. So actually, this is -1. And then all the way on the bottom is 1. In the middle, then, would be 0. So guess what? Our motors want a value between -1 and 1, with 0 meaning don't do anything. Our joystick sends a value between -1 and 1, with 0 meaning the joystick is in the middle and we're not touching it. That's like perfect. They are matched up. All we got to do is take the value we read in from the joystick and pass it to the motor, and it's going to do what we want. Now, what we're going to do first, we're going to actually drive the robot in a couple different ways, but the fastest and easiest way to get it set up and tested is we're just going to take this y-axis on the left joystick. We're going to send that value to the left motors. Then we're going to take the y-axis on the right joystick, and we're just going to send that to the right motors. So if we push both of the joysticks forward together, the robot will drive forward. If we go backwards on both joysticks, the robot should back up. And if we go forward on one joystick and backwards on the other, that should make the robot turn. And as you have, I'm no doubt aware, you have found out that there are no steerable wheels on this robot, right? So the only way we can turn is like a tank. It's called tank drive or differential drive. And if we run one side of the robot forward and run the other wheels on the robot backwards, that is going to mean that the one side goes forward, the other side goes backwards, which leads to the robot spinning in a circle. All right, so that is our goal. Then I'm going to give you a slightly better way to control the robot, and that's the one we're going to leave it off with. But you can always leave the tank-style drive in if you want. All right, so back to our code. We are now looking to set a value here. And the value that we want to set for our left drive is a value that we're going to read in from our gamepad. And remember, our joystick is called JDrive. And we're going to do a dot. And in JDrive, look at this. We can read all of these different things. And the question is, which one do we want? So in this case, we're going to do get raw axes. So you can do get raw axis. OK, but how do I know what axis is what, right? Like we looked at the joystick, and we've got up and down on the joysticks. We've got left and right on the joysticks. And actually, these triggers on the side, those are also axes, although they start at 0 and they go up to 1. They don't go negative. So we have all those different axes, and we have to figure out which one is which. And the answer is, if I knew, I could just tell you, but I don't know. Here's how you find out. Let's go back to our desktop, and we're going to run the FRC driver station app again. Yes, always. It's fine. Do what you want to my computer. All right, and this pops up, and I'm going to take my gamepad here, and I am going to plug my gamepad USB into the computer. Of course, I'm going to cancel that. All right, so gamepad, let's plug it in. And now, when I go and look at this, so I don't know, this is the USB symbol So it's kind of the fourth tab down. You now see there is a controller, Gamepad F310. If you have like an Xbox controller, it'll say it's an Xbox controller. All right, but look next to that. So this one is highlighted. If I have multiple ones, I can highlight the other ones. I don't have multiple ones, so make sure you're on 0, which is the one that we highlighted. And remember, I also told you when we were setting them up, JDrive, which is the gamepad that we want to use to drive the robot, is set as ID 0. So perfect, it's here. If we wanted it to be a different number, you can actually just left-click and drag this and put it wherever you want. So if yours is not 0, drag it to 0. Now, next to that, look at this. We have axes and we have buttons. And if I press buttons on the gamepad, look at that, they light up. So the first one that I press, so it looks like A, the A button, is lighting up this top light here. That means this is button number 1. And then I can keep going. So next is B, and then X, and then Y, and then the bumper, left bumper, right bumper, and then we have this POV hat. What are these? These are like pushing down on the gamepad. Okay, there's the back button. And so anyway, you can find out what number a button is by doing that. That is the same thing we're going to do with the axes. So we want to find out the left stick y-axis, right? That's what we want to control. So if I move the left stick forward and backwards, it is in fact number 1. Axis number 1, not 0. Oh, the button maybe starts at 0 too. We'll figure that out when we get to buttons. But you can see the left axis when I go forward and backwards on the left stick is that bar is going forward and backwards. So I know that is the one we want. So the left side is going to be axis 1. And the right side, if I do it, is going to be axis 5. So we're going to be using 1, and we're going to be using 5. OK, cool. Back to the code. You can leave this driver station running. It doesn't hurt anything, unless your computer is very slow and is struggling with that, in which case close it. All right, got a moment to help with the VS Code team? Not right now. So axes, we said 1. The left side should be driven by axis 1. So I'm going to put a 1 inside my get raw axes. Then, guess what? We need to do the other one. So drive right spark dot set, and then inside the parentheses, it's going to be JDrive. We read the value from our joystick that is our driver joystick, dot. And we are going to do get raw axes again. But this is the right side. And remember, the right side was number 5 is what's moving back and forth for right Y. All right, cool. So this is going to be number 5. All right, and now, of course, we have to do the victors. So we have 2 motors on the left, 2 motors on the right. 1 each is a spark, and 1 each is a victor. So now we're going to do drive left victor dot set. Now this one's a little weird. We have 2 things that it wants us to type in here. So we're going to tell it what kind of control mode we want to use, and then we're going to give it the value for that. And in this case, the control mode that we want is control mode dot, and we're going to do percent output, which is basically everything I've been explaining to you is what percent output is. It just so happens there are other ways that you can control the victors. And then instead of kdefault period, that is where we were going to put our value in. And our value, we already know what it is, right? We can just read it again, jdrive.getRaw, and that is going to be axis number 1. And finally, drive right victor dot set. Again, we're going to do control mode dot it was percent output, comma, and then we again replace this with jdrive dot get raw axes, and this one was number 5. And for some reason, in my tabbing and deleting and tabbing, I've got an extra parentheses out here, so I'm going to delete that. That's why I had the red squiggly line. And theoretically, at this point, we would be able to download this code to the robot and drive everything. But remember what I said about we do not want to have motors fighting each other when they're in the same gearbox. So in order to solve this problem, we do not want to control we don't want to turn all the motors on at the same time. So what we're going to do is we're going to comment out lines of code. And commenting something out, like I should have mentioned this earlier, but all of this green stuff that we see that is just in English, like this autonomous along with the chooser code above, blah, 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 these are notes for people. The robot ignores them. They're not really part of the code. They're just like comments that we can put in so people can follow along with what's going on. And one of the ways that you kind of debug or test your code a lot of times is you can debug or you can comment out lines of code so only specific stuff runs until you know that part works. Then you can comment out the next one, and so or comment it back in and comment out the next one and so on. So what we're going to do here is we're going to start with left spark, and we're going to put 2 forward slashes on the next 3 lines. And you see how they turn green? That is how you make a single line comment. So everything behind the 2 slashes is ignored and will not run. It's like it's not even there. So really what we're here to test is if we, wait a minute, hold on, I'm not in the right place. After I scrolled around, that was in init. Leave init alone. We want all of them to be coast. But in Teleop periodic, where it's drive.set, whatever, right? Those I'm going to comment out. Okay, so drive left spark.set, jdrive get raw access 1. So the left joystick going forward and backwards on our gamepad should make one of our 2 left motors move forward and backwards. And our goal is to find out, does the robot move forward and backwards when we do that? If so, we're good and we can move on to the next one. If not, we got to invert it. Okay, so we're ready. We're ready to send this code to the robot and move on, but we've been doing all this coding without the battery in the robot. So I'm going to go grab the battery, put it in the robot, turn the robot on, then we'll go ahead and get connected to the robot, and we'll be able to do our first test. All right, so I put the battery in, strapped it in. I'm going to make sure my plugs go together and turn the robot on. Oh, we're up to 12.5 volts, so it did well on the charger. All right, so once your team number pops up, go ahead and click on it. And you can connect automatically. You probably want to connect to your robot when you have the option. And remember, it will be no internet. That's cool. And open, that's perfect, because I didn't put a password on mine. All right, now that I'm connected, I should be able to build and download my code wirelessly to the robot. Let's give it a try. So we're going to hit the 3 dots in the upper right-hand corner here and build robot code. So building is like taking all the stuff we have. It's going to compile it down, turn it into language that the robot's going to understand. And I don't know how long this is going to take, but we're going to find out. 9 seconds. Definitely faster than that first one, which was, I can't remember, 39 seconds or something. All right, so now we have this code all kind of built up and ready to go to the robot. Then we're going to click the 3 dots, and we are going to deploy robot code. So that sends the code to the robot. Also, we still have one unused thing. Oh, we didn't control mode. I thought I did control mode. Interesting. All right, so that is working. You'll see down here, 68%, still executing. Oh, I get it. I was wondering why we had the yellow back, because like we did control mode, right? But then we commented the control mode out, so that's why it thinks we have one unused import. Makes sense. All right, we're still waiting. One of the things you can do here too is before you do the deploy, right, if you have your driver station up, you should see communication green. And if communication is green, that means you can definitely start downloading stuff, and it should actually get there. All right, look at that. OK, we might have to go back and do firmware on our Victor SPXs. Cool. If you're getting those errors, it's OK. We'll just clear it for now. Look, we have green for communications, we have green for robot code, and we have green for joysticks. Joystick is controller 1. So now we're going to go back to this top tab, which is kind of like the driver tab. And we have some options now. We only made a teleoperated program, so we're going to go to Teleop. And there's a few things you have to know right off the bat. So we have this enable button. That's going to enable the robot. It's going to be able to drive around. When you're doing that, you got to have safety in mind. People should be back away from the robot. They should definitely not be near any of the pinch points, chains, anything that's really scary on the robot. And you can hit the disable button again to turn it off. The disable button will disable the robot and make it safe. But also, in an emergency, you can hit spacebar, and that will e-stop the robot. If you do spacebar, though, you will not be able to use the robot again until you turn it off and turn it back on. And I guess, just to be extra safe, let me grab a pair of safety glasses. So when you're at the competition or in the pits at the competition and robots are running, they're always going to have you wearing safety glasses. So you might as well get used to it. All right, and what we need to do now is I'm going to click this enable button, and I'm going to be ready to hit disable. If the robot moves when I click this enable button, there is a problem. I'm disabling right away. And we're good. We're good. All right, then, in theory, right, if I get my gamepad, if I push forward on the left joystick, the left motor should move somewhat. Oh, look at that. And I pushed forward and the left joystick and the left wheels went forward. So that's pretty good. All right, and of course I have no other controls. That's literally all the robot does right now. But it moved, come on, that's good. It's progress. All right, so I'm gonna go ahead and disable the robot now. And you know what? Our first bit worked fine. So let's go back in our code. And I do not need this second window here. I'm gonna close that second window. Okay. So our first one worked. Now, there is a small problem, and that is, remember I told you how the gamepad actually reads in negative? So really what we wanted to put here in our drive left spark.set was not JDrive. It should actually be negative JDrive.getRawAccess because our y-axis is negative, which means the fact that it went the right way means it's actually going the wrong way. So let's go back up, scroll up in the code, and you can resize this output window if you want to see more code, but I'm going to scroll up in the code until, remember that where we set inverteds? Drive left spark.set inverted. Turns out that should be true. Let's turn that to true. All right, scroll back down. Scroll back down, scroll back down, scroll back down. Wait, not that far. Scroll back up. All right, find the line where we have the left sparkmax.set, blah, blah, blah. Now, we are going to comment out that line of code. We only want to run one motor at a time until we know they're all going the same direction. I'm going to uncomment the next line of code. And actually, let's go ahead and add that negative sign in now. We're going to do negative JDrive. And then down here on the other lines of code, let's also do negative JDrive. All right, so we should have that on all of these. They should all be negative JDrive now. All right, but we're ready to test our right sparkmax to see if it is going in the correct direction. So 3 dots, build robot code, wait for it to finish, 3 dots again, and deploy robot code. All right, and then we're going back to our, I think there's probably a way to make this not pop up every time, but I'm just going to hit the X button and make it go away. And I'm going to bring up our driver station again. So once again, I'm going to enable it. And now I'm doing the right joystick forward and backwards. So when I push forward on the right joystick, does the right wheels go forward? They do. And we put the negative JDrive in. So we're reading the negative value of the joystick, which is what we actually want. So this one, I think, is correct. All right, let's hit the disable button. And back to the code. We don't have to invert this one because it was correct. So instead, we're just going to comment it out and uncomment the next one. Drive left victor.set, right? And this is negative, so now we're going to try the other left motor and see if that one works right. Hit the 3 dots, do a little build robot code. And this is just how programming goes. It's a lot of small changes, downloads, tests, small changes. All right, 3 dots, and deploy robot code. All right, build successful. Let's open up our driver station again. Enable it, and once again, I'm back on the left side now. And we want to know if forward on the left goes forward. So let's try it. Forward on the left. Did nothing. OK, so what I think that means is now we tried to use, for the first time, we tried to use the Victor. And those error messages that we're getting, which is that the CTR firmware is too old, I think we have to upgrade the device. So we're going to do the Windows key. I know we should have done this in the last video, but we got surprised. We're going to run Phoenix Tuner X. Okay, and on the 3 lines here, we're going to go down to where it says driver station, or yeah, driver station. Oh yeah, we want driver station. Pick driver station. And actually switch to something else and then switch back to driver station. There we go. You want to see the 10.your team number down here, and it wasn't doing that when I picked driver station the first time, so we had to kind of go through it. Anyway, go to devices, and then we've got our first Victor SPX here. It does say a new firmware version is available. I think if I were reading in the last video, I would have noticed that. Anyway, scroll down, and we have this pull-down menu here, which is select CRF or press browse. We're going to grab the Victor SPX application 22.1 season 2023. Pick season 2023, and then hit update firmware. And we got our progress bar going, so we're just waiting until that finishes. Successfully updated firmware. Guess what? We got to do the other one, so click on your other Victor SPX over here. Scroll down, same thing. Pick the 2023 season and update firmware. Successfully updated firmware. All right, I'm going to close Phoenix Tuner. And then what we're going to do is, I think we want to power cycle the robot. And by power cycle, of course, I mean we're going to turn it off and on again because we put new firmware in. It's better if everything reboots and starts over. So I'm going to turn it off, and I don't know if this is strictly necessary, but with electronic devices, I always wait a few seconds after I turn it off so that any capacitors and stuff can discharge. I don't think I've ever run into a problem doing it instantly on an FRC robot, but we'll just give it those few seconds, turn it back on. And now guess what? We have to wait that 30 seconds to a minute for the radio to reboot. But just to be ready, I will open up my driver station. And as soon as I get communication here, then we know we're in good shape. Also, you might get a lot of errors. You can click on this gear and choose clear. Clear those errors out. You can also, we definitely don't want warnings. And I don't know, how long was that? That was maybe 20 seconds. This is not fair though, because you can just look at the time code on the player, so you know exactly how long it's been. It's got to be getting close. Oh, you know what else we have to do is, just in case my wireless network connected to somewhere else, I am going to open up my wireless networks. Oh, there it is. It just connected. We're good. That's how long it takes to reboot your robot radio, which is why I was so particular about making sure that all of our power wires are good, because if you lose power for even an instant during a match, you're out for that long. However long that was, that's how long you're out in the middle of a match. All right, let's click Enable, and let's see if it works this time with our updated firmware. Yes, it does. And interestingly enough, backwards is backwards and forwards is forwards. So we don't have to change anything on that one. All right, cool. Let's disable. Let's go back in the code. So now, at this point, let's do the last one. Let's do the last one. We'll just finish it up the way we've been doing it. So comment that one out, uncomment the right drive Victor. And once again, 3 dots and build. OK, back over to our driver station here. Let's enable it. So now, again, we're checking the right side joystick. Let's see if backwards goes, backwards goes forwards, and forwards goes backwards. That's not good. We need to fix that, because again, otherwise the motors are going to fight each other. So double check. I'm pressing backwards on the right stick, and we are moving forwards. I press forwards, and we move backwards. So hit the disable button, back to the code. Now we are going to actually uncomment all of these lines of code. And if yours did not do what mine did, just remember, if it ever went backwards of the direction you pushed the joystick, that's when you got to scroll up to this top section here where we put is it inverted, and the right Victor is true. That was the one we just tested. So we're going to go true on that right Victor. And again, yours might be different. I said I've seen motors that are wired differently. Looks like the Victors and the Spark Maxes work kind of opposite directions, which was interesting. Anyway, so we have that set up. So mine is left Spark true and right Victor true, and then right Spark and left Victor are both false. come back down. Now everything is uncommented. This means that when we actually try to run the robot this time, we should have full control of the robot, but it also means that we want to be extra careful because the motors could still fight each other if we made a mistake. So let's build it. And then, of course, we will, as soon as this finishes, deploy it. And as soon as that finishes, back to the driver station. All right, I'll close that again. Back to the driver station. We're going to enable it. And if it doesn't move, like if I try to move the joysticks and it doesn't move, then the motors are probably fighting each other. We want to stop and figure out, go back and redo the test to see whether it's forward or backwards until it is correct. So right side forward, moves forward. Right side backwards, moves backwards. Left side forward, moves forward. Left side backwards, moves backwards. So now, if I do both of them forward together, guess what? We can actually drive straight forward now. And if I do both of them backwards together, we can drive backwards. And as we were saying before, forwards on one and backwards on the other, and we can turn. Okay. You might not want to push the joysticks all the way forward right now. We did talk a lot about, as we were building this, we will probably need to add ballast to this robot. You can see just as I accelerate, it is not super stable. So right now, make sure you are gently pushing the joysticks a little bit to test your robot. And one of the plans, I think I don't have the official plan yet, but it is going to be adding some weights on the bottom of this robot, somewhere between 40 and 50 pounds of weight as low down in the robot as possible. That is going to get our CG lower. That is going to make the bouncing that you just saw hopefully get a lot better. But the good news is we just programmed the drive on a robot. That was tank steering. We have the left side working. We have the right side working. We have the motors not fighting against each other. Let's go ahead and disable this, though. And we're going to make a small change to the way that the drive is programmed here. First of all, there is another way that you can drive stuff. And that is, instead of having the left joystick controlling the left wheels and the right joystick controlling the right wheels, which is okay. We just did that. That's kind of the old style tank drive, and it works. Another thing we can do, though, is think about this. If you needed to drive, like we are lined up with the cone, right? We have the cone. We're almost ready to drop the cone. And you have to move forward like 4 inches. With this tank steering mode, it was really hard for me to get both of them going at the same time. So when you try to like creep forward with this style of driving, if you're not perfectly pushing them forward evenly the amount you need to, your robot's going to start to turn. And if you are already lined up with the goal and you start turning away, then you got to start turning back the other way, and it can be really hard to make some of those fine adjustments. So a better style of control, I think, and this probably is going to be more popular with any of you that have played a first-person shooter on a console. The left joystick, forward and backwards, should just make the robot drive forward and backwards. That's it. Forward, backwards, straight forward, straight backwards. Then what we can do is we can use the right joystick side to side, or you can put it on the left joystick, doesn't matter, but then we'll do a sideways on the other joystick, and that will make the robot turn left or right. So then if you just want to move straight forward, you can do that, and if you just want to turn in place, you can do that without having to mix and match the throttles to get it to do exactly what you want. So we're going to change it to that style drive, and because we want to get kind of back to where the Everybot code is, we're going to use like kind of a class here. We're going to take all of the drive stuff and put it together in a different part of the program so that in Teleop periodic, all we have to do is say, hey, here are the joystick values, make my drive work. And the reason why we're going to do that is because then in auto mode, when we're programming autonomous mode, we can also just say, hey, here are the joystick values I want you to pretend that you got, and go take care of the drive. All right, so what we're going to do is in Teleop periodic, we're still going to do some stuff, but all of this setting of the drive motor, we're going to take somewhere else. So highlight those 4 lines of code that we've been working on, and let's do a cut. So Control X. Wait, are you highlighted? There you go. Control X. There we go. And we are basically going to make our own class here. And you can add this pretty much anywhere you want. I'm going to go down. Well, I guess I'm going to go up, and we'll add it above. Robot periodic, because that's, or maybe above autonomous init, above robot periodic. Yeah. So we'll add it here. So this is above all of the other things that are going to use it. and we're going to make our own new thing. And it's going to look a lot like the other ones, right? So we had in robot init here, for example. We are going to basically make something that looks like this. So we're going to do public void. And this time we're going to call it, let's call it set drive motors, because that's what we're doing in it. And we're going to do an open and close parentheses. And inside here, so this basically, we're going to call this where we basically had these lines of code before. And when we call this, that is going to come up here in the code and run this stuff. And when it's done running this stuff, it'll go back down into Teleop periodic and continue where we were going. But in order to set the drive motors, we have to send them some information. So we're going to send them a double. And a double just means that it is a double precision floating point number. All you have to know is when we say double, it means that you can use decimals. It's a decimal number. If we use int or integer, that means it is an integer. It's only the whole numbers. And so we're going to pass in a double, and we want to know the forward value. Remember, we're changing our drive not so that we have a left side value and a right side value, but we have a forward and backwards value, and then we also have a turning value. All right, then we're going to do another one, double, and this one is going to be turn. So we need to pass in the forward value that we want to use and the turning value that we want to use, and when we do that, this code will take that information and actually do what it needs to do to send it to the motors. Now, there's another thing that we're going to do in a few places. You can skip all of this if you want. This is kind of for debugging your robot and to figure out what's happening. So there is something called a smart dashboard. So if you type smart dashboard or smart and then tab, you get the smart dashboard. And the smart dashboard is, right now we don't have it up, but if you look here, this is our current dashboard. This is the LabVIEW dashboard. We're going to switch that to a slightly different looking dashboard that we can actually send information to. In order to send information to this one, we actually have to open up a whole LabVIEW project and edit it. So the smart dashboard is a little bit easier for us to pass data back and forth from the robot to the driver station. So if we do smart dashboard dot, we can do put number. And inside put number, the first thing we do is we can do a quote. And that was too many undos. All right, we can replace this inside the quotes with the label that we want to show up. So for example, what we're going to do here is our drive forward power. And we're going to do a parentheses, percent parentheses. So this label is going to show up now on that dashboard that says the drive forward power is, and that percent parentheses, parentheses, percent parentheses. There we go. That is going to be the value that we pass in after the comma. So it's going to be a comma, and then we can do our forward value. So this is going to tell us what our forward drive power is. And if you copy this entire line of code or retype it, up to you, we can do another one of these for not our drive forward power, but our drive turn power percent. And then, of course, we need to pass in turn. And make sure for both of these lines that you have added that semicolon. So when we run the program now and this gets called, it's just going to put these numbers on the screen. And we can know, oh, OK, I pushed the joystick a little bit forward. It's reading 20% power. That makes sense. OK, the next thing we want to do here is actually do the math that figures out whether we should be going forwards or whether we should turning, right? We have to combine the forward and backwards on one joystick with the left and right on the other joystick and make everything work out right. And so here's the math. Ready? We're going to do double left equals. So what we're doing is we're creating a new variable called left. This is the value that will be sent to the left motors after we do our calculation. And that value is going to be equal to, well, if we just press forward, that's the value that should go to the left motor, right? So it's going to be forward, that forward value. And if we try to turn, we basically are going to either add to the forward value, right? If the left side is going forward and we want to turn to the right, the left side is just going to go more forward while the right side goes backwards. If we want to turn to the left, then we want to have the left value get smaller. And so all we have to do, I think, is add a minus sign here and subtract turn from it. So now if we don't have any turn, we stay put. If we don't have any, and we have forward, we'll go forward or backwards in a straight line. If we don't have any forward and we do turn, then we're going to turn, we're going to go negative the turn value. And if the turn value goes to the right, that's positive. So yeah, so that makes sense, right? So if we take the joystick and we go to the right, that is +1. And so we would want the left motors, though, to be going the opposite direction. We'll see. I'm not 100% sure if this sign is correct, if it should be a minus or a plus, but we're gonna test it. We're gonna find out. All right, and then we'll do another double right equals, and this one is gonna just be the opposite. So it's forward plus turn. So all we have to know is whether our turn is adding or subtracting from the value of our forward joystick. And yeah, I think it works out. I think it works out because I think the joysticks are backwards. All right, so that is the math. We're done. Math is done. Now all we have to do is output the values. Well, let's do another smart dashboard because this is going to help us find out if stuff is backwards, right? So let's do another smart dashboard. Actually, you know what? I want to copy. I'm just going to copy this line of code right here, smart dashboard.number. We're going to post that in, and instead, what I'm going to say is now it is not the drive turn power. This is drive, we're going to do left power, and I'll change turn to left. And then guess what? We're going to paste it again. And this time, it's going to be right and drive right power. All right. Then we're ready. What? It's good. Undo fixes everything. All right. Then we're ready to actually hit Control. Uh-oh, wait. Oh, no. We had that stuff copied from before, and I forgot to paste it. Well, you know, that's OK. We wanted more practice writing those lines of code anyway. So what do we have? We had drive left spark, right, dot set. And then inside we put the value. If this is a left motor, guess what? The value should be left, right? Because that's what we calculated. Our left power here is what we send to our left motor. So that one's done. Then we can do drive right spark dot set, right? And that should just be right. We made that variable right. We calculated what it would need to be based on our forward and turn, and that's what we passed through. Then we're going to do drive left Victor dot set. And then remember, this one's a little different because we have to do control mode dot percent output. And of course, this is the left Victor, so we need to be typing left here, not right. And then I'm just going to copy this one, and I'm going to paste it. And we're going to change left right here to right. And we're going to change left Victor to right Victor with a capital R. All right. So those 4 lines of code, I think we still had to modify them a little bit because they had our joystick values in there, but we did them again. Extra practice. All right. This is, I think this is done. So this is our little class, which is going to set drive motors whenever we want. But we have to go back down now to Teleop periodic, which is empty now because we took everything out. And in Teleop periodic, we actually have to call that class. We have to say, hey, here are the joystick values I want you to use, and now I need you to go and do the thing that you are doing. And so we call it by basically typing the name of it. So we had set drive motors, right? That's what we called it when we created it. And remember, it wants 2 things. It wants forward value and a turn value. Well, our forward value is easy. That is just minus j dot get raw axis. Minus j drive dot get raw axis. And remember, that was axis 1, because that's unchanged. That's the left joystick forward and backwards. Then for turn, though, this one, I don't know what it is. It's going to be an x-axis, so it doesn't actually get a minus sign, I don't think. We'll find out. If it's backwards, then it needed to be the other way. So this one, we're going to do j drive dot get raw axis, And which axis is it? I don't know. Let's open up our driver station and find out. Go back to the tab here. And what I like is forward and backwards on the left stick and turning on the right stick. So right now I can see that is axis 4. Okay, cool. So right here, we're going to change it to axis 4. And that's it. Now we send these values to that other class that we wrote earlier. It figures out what the left and right motor should get, sends it to the left and right motors, and we're good. So at this point, we are ready to build the robot code. Then we're going to deploy it. Then we're going to test it and see if it works. And if it does work, great. If it doesn't work, we're going to figure out why, and we're going to fix it. All right, build successful. And now we deploy robot code. All right, perfect. Close that thing. Now, if I minimize this, remember we have these two things that are open here. And this is not the dashboard we want to use. So every time you go to use your robot, and it should remember this, by the way, in between uses. If you go to the Settings tab, the gear here icon on the side, underneath where the team number is, we have Dashboard Type. It's on default. What we want to use is Smart Dashboard. Click Smart Dashboard. And it's going to make the old dashboard go away. It's going to make a new dashboard show up. And here's what's cool. So this one has the autonomous mode choosing ability that we talked about before. So that's still there. But watch what happens when I go back to the Drive tab here and enable. And all of these things are here, all that we talked about: forward power, turn power, left power, right power. And what you can do is if you go to View, you can choose Editable, and you can drag them around. So now we have our forward power and our turn power, which is going to change when we actually use our joysticks. And that is going to dictate our left power and our right power. And you can sort of arrange this however you want as you're doing it. OK, so we are enabled. Let's test it. If I push forward on the left joystick, the whole robot should drive forward. Let's try that. OK, good, good. If I go backwards on the left joystick, the whole robot should drive straight backwards. Perfect. So we have that forward and backwards. And this is what I was talking about. Look how easy it is for me to, if I just had to creep forward a little bit to line everything up perfectly, no problem. And it's straightforward. All right, let's try our turn joystick. So that should be the right joystick going left and right. So I'm going to turn to the right here, and the robot should turn to the right. Oh, that's left. And that's right. So that one's backwards. Let's fix it. Disable. Back to the code. There's the code window. And I think what it is I think I was thinking that we were going to make this negative. But the x-axis on the joystick is not flipped like the y-axis is. So I think we leave this positive, but that does mean if we go back up to find your set drive motors class here, and what that means is our minus for the left side should be a plus, and our plus for the right side should be a minus. That's going to change the direction that we turn. All right, yeah, we're just going to test it again. So once you have that done, go ahead and build, and then we'll deploy, and then should work. Then the drive will be completely done, and we're ready to move on to the arm. We're deploying now, so should come up in a second. OK, and now let's see if it works. Back to our driver station. Let's bring up this Smart Dashboard too. I'm going to go ahead and enable. And so turning to the right now makes my robot turn to the right. And turning to the left now makes my robot turn to the left. And we can try to combine them, right? So I'm going to drive forward, and I'm going to drive forward slowly, but I'm going to go forward and turn to the right while I'm driving forward. OK, and if I go forward and to the left, that also works. So I would say that our drive is now good to go. We are done with our drivetrain. Don't go fast on it. We gotta, maybe we'll add something later that lets us actually slow that down, because especially until we get some more weight on there. All right, let's disable. Drive is done. Next up, we are going to start working on the arm in and out. Okay, so let's start working on this arm motor so we can extend this thing out and pull it back without, me having to reach over and do it. All right, so in the code, first thing we have to do, scroll all the way up to the top. We're good on our imports. We don't need any more imports, but what we do need is, as you scroll down, right underneath public class robot extends, we've got our auto mode stuff, our chooser stuff, but then remember we created these left drive, right drive spark, left drive Victor, right drive Victor. We don't have the ARM one in yet, so that is the next one we have to add. I'll leave a little space there, but basically it's on a Spark Max, right? So we start with can Spark Max space, and this one is going to be our ARM. So, we can just call it ARM. Seems reasonable. Equals new. And remember, ARM, you want to call it something else, call it that. That's just a name, can be whatever you want, but it is going to be a new can Spark Max. And the device ID is 5, right? 1, 2, 3, 4 on the drive, 5 for the ARM, 6 for the intake, 7 for the PDH, the power distribution hub. And the type of motor is going to be so we are going to replace this null, and we are going to do a motor type dot, and this one is brushless, so we're going to do K brushless this time. I'm going to pick it. And add a semicolon at the end of that line. Don't add a whatever else I hit, L. Okay, so now that motor exists, or that motor controller exists. We can reference it. We can control that motor. Moving right along. We also have our joystick for the driver. Now, you could put all of the functions on one gamepad and have one driver do everything. On this robot, I would recommend having 2 drivers, and most teams in FRC will have 2 drivers, right? One doing the driving, and the other person making sure everything else is in the right position. So grabbing cones, spinning cones. It's just, if you share the mental load there, and they practice together, they can be more efficient than one person doing it on their own. So that means we will need a second gamepad to use. So we're going to do another joystick. And this one I'm going to do J, and this is going to be, I'm going to call it J arm, because J operator is more letters, and I don't want to type that many letters. And it's going to be a new joystick. And the port for this one is 1. Remember I said we just use 0 and 1 because we can drag them around and put them wherever we want. All right, and that also means I will take another gamepad, and I'll just plug that into my computer just so we have both of them going. I'm going to move the drive one out of the way because we're not working with that one for a bit. If you do not have a second gamepad to plug into your computer, that's okay. Because remember, on the driver station, right, so now I have 0 and 1. If you didn't have this number 1, you could just drag the 0 to number 1 for a bit, right, and work on the code that we're doing now, and then you could drag it back when you wanted to work on the driver code. But now, see, what has happened was I've dragged these around, and I actually don't know which is which. So I have no idea which one of my gamepads is which. You can figure that out because remember, when you press a button on the gamepad, look at that, it lights up and shows you what button is being pressed. So because I'm pressing a button on controller 1, I know this is my ARM controller. And if I press a button on the other one, I know that's my drive controller. So I did manage to drag them back in the right spots after all. Okay, back to the code. Now, there's another thing we're going to do here. And this might be a little bit confusing, but it is generally good practice. If we put a bunch of our set variables, like for example, this arm, we're not going to need to control the power. It has 2 positions. It's either all the way in or all the way out. So we don't really need the fine control. Like when we're driving, we want to be able to go slow. We want to be able to go fast. Here, it really is just like there's one speed that this arm moves. That's a good speed for the arm to move. And when you have things like that, where it's always going to be the same speed, it's nice to put them all in one place. Basically, we're going to make a variable here where we set that speed. And then, if anything changes on the robot, we don't have to dig through the code and find all the places where the numbers were, remember what the numbers were. All we have to do is come into our list of things here and change the number in one place. So that's what we're going to do next. So we're going to do a static. Static means it is unchanging. Final, and it's going to be an int. And there are 2 settings that we want to do here. There is something called a current limit. We can use these speed controllers to limit the amount of current that is going to the motor. That means when the arm is, like, for example, fully extended, if we want to keep powering it a little bit by having a current limit, that's going to stop it from burning itself out. So we're going to do a arm current limit. And the general convention for these things is when you are creating these user variables that have values, that have numbers that aren't going to change, that we're going to use in the program, is to make the whole thing capital letters. So I'm going to do arm underscore current underscore limit underscore, and then A for amps, I guess. And of course, this is still just, and it equals 20. This is just a name, so if you don't want to type all that, that's fine. Here's the good news. Later, when I type arm underscore C without doing capitals, current, there it is. I can tab complete it. So it's annoying to type it out the first time, but sometimes it's worth it to have a very descriptive value there that's not going to lead to any confusion later. All right, the next one that we're going to add is our arm output power. So that is going to be another static final. This one, though, is not going to be an int because when we control the arm, just like when we were controlling motors before, we want to use decimals. So this is going to be a double. And I'll call it arm underscore output underscore power. And that's going to equal 0.4. Okay, and those numbers, these two numbers are current limit for the arm and our output power for the arm. Those are just coming from the Everybot group. That's what they tested on their robot. So if your arm doesn't move quite as quickly as you want it to move, we just come back in here and say, okay, now it's 0.45, or now it's 0.5. If your arm is moving too fast and it's slamming into the ends and it looks violent and it scares you, it's okay, 0.35. You can adjust this number to suit your robot. But we'll start at 0.4 because that was the number that we know worked on at least one robot. All right, then let's scroll down, scroll down, scroll down. We're looking for robot init. I'm going to jump into robot init here. And I'm going to add an extra line on the bottom of it. And what we're going to add here is we need to add arm dot set inverted, just like before. Right now, let's set it false, and we're going to find out what happens. Okay. Then we're also going to do arm dot, and we need to do set idle mode. Do you remember idle mode? We have brake and we have coast, and the idea is, again, when the arm is not getting power, we want brake mode on because we want the arm to kind of hold its position out or hold its position back. We don't really want it to sort of start slowly sagging down. So brake is not going to be perfect at holding it in a position, but it will help resist the movement a little bit. So we are going to do set idle mode, and it is going to be idle mode dot kbrake. Okay, and that line looks like I need to add a semicolon still. And we have one more thing that we're going to add here, and that is we're going to put our smart current limit on the arm. So we're going to do arm dot, and that is set smart current limit. And the current limit is going to be, hey, guess it knew what I wanted, arm current limit A. So if that pops up for you, great. If not, you can just start typing arm. And you don't even need to caps lock it. If you do arm underscore C, there it is, hit tab, it makes it all uppercase for you. And then hit a semicolon. So now we have set our arm current limit, we have set the brake mode, and we have set that the arm is not inverted, although we may want it to be inverted. We're going to find out. Okay, looks good. So now let's move on. We're moving on. We're moving down in the code. And underneath the set drive motors, just because we want this to work kind of the same way, to where we have the drive class that we can use in Autonomous and Teleop, we want an ARM one that does the same thing. So let's get underneath set drive motors, and we're going to make a brand new one that is a public void. And this one is going to be called set ARM motor. And then we'll do open close parentheses. And we basically only need to pass one thing into the ARM motor, and that is the percent value that we want to send the ARM at. So we'll do double, and then let's say percent. So this is percent power we want the ARM to run at. Okay, and then the end of this line is not semicolons, right? It is an open and close curly brace. Hit enter in between them, and we can add our lines of code. And the lines of code, it's basically going to be arm.set and percent. If percent didn't show up, you can type percent in. Okay, and then the only other things we're going to do is, hey, look, we can do some more of that smart dashboard stuff. You can skip all the smart dashboard stuff if you want. I'm going to throw it in. I'm going to do a smart dashboard.put number. And let's see. I'm going to do quote, and my quote is going to be arm power, and we'll do a percent sign. Percent sign inside the parentheses, comma, and then percent is in fact the arm power, so that line is good. Get a semicolon at the end. Copy that whole line. Let's hit enter. Let's paste it. Now this time we are going to do arm, and we are going to make this be current. Oh, I guess it would be arm. Let's do arm motor current, which is our amps limit. Okay, and then over here, instead of percent, we're going to do arm.get output current. So this is we can read in the current that's going through our SparkMax, and we can see what the current is at any time on our arm. And actually, there's another thing we can read in too, which is like, so this is all debugging stuff. If your arm starts to go to high currents or is always pegged on current, we might need to increase the current limit. This is a way for us to see what that is. Otherwise, we would just be guessing. And then we can also, let me paste again. We can also do, instead of that, we can do arm motor temperature, and that is in degrees C. Celsius. I guess that's capital C for Celsius, so comma, and then this is going to be arm.get motor temperature. There it is. It found it for me. All right. So now when we run this, we're going to have 3 new things on our smart dashboard that we can keep track of: the arm power, the current that the arm is currently seeing, and the temperature of the arm. I guess it's really the arm, not the motor of the arm, but it is the speed control of the arm. All right. That looks good. That's all we need in our void set arm motor. So now we actually have to go down to Teleop periodic, because that is where we actually are going to run it from. So find Teleop periodic. We have our first line of code here, which is set drive motors. That's fine. We can leave that alone. Now, what we have to do here, though, is we are not just taking values, reading values in, and sending it to the motor. Instead, we have to do some logic. And the logic is basically on this controller, what buttons should do what. And I'm kind of thinking, I'm going to save these 4 buttons for the intake. And I'm thinking, I like kind of the top 2 buttons here, the bumpers, left and right bumpers. Those are easy to use buttons. So I'm going to use the left and right bumpers to make our arm go in and out. Now, you can pick whatever you want. Let's go to our driver station. And I'm going to click on Gamepad 1, because that's the one I'm holding. And I'm going to press this button. That looks like it is button. So I think it's 0, 1, 2, 3, 4. So I think 4 is left bumper for me. And if I press the right bumper, I think that's 5. So I think I'm going to be using buttons 4 and 5 for mine. But if you want to use different buttons, if you want to use A and B, or if you have a completely different gamepad and you have circle and square, that's fine too. Just figure out the ones you want. And that's what we're going to use when we write our code here. So the first thing that we're going to need is we are going to basically figure out what arm power should be sent to the arm. Remember, we made this variable up here, way up, like it feels like it was forever ago. There it is. We have arm output power right here. And it is 0.4, right? So we have this arm power, and I'm going back down now to where we were in Teleop periodic. So basically, if we press one button, we want to send that power to the arm. If we press the other button, we want to send negative that power to the arm, so it goes the other direction, right? And then, if we don't press any buttons, if we're letting go of all the buttons, then the arm should just get no power. It should just stop. So we're going to do a double. We're creating a new variable, double precision, so we can use decimals. And I'm going to call it arm power. And it can start out by not being equal to anything, because we are going to give it values in our next lines of code. And now we're going to do a conditional. Basically, it's what I said, right, in English. If you're pressing one button, send forward power. If you're pressing a different button, send negative power. If you're pressing no buttons, send no power. And the language for that, we just start with an if. You say if. And then after the if, you do an open and close parentheses. I don't think you need to have a space between these two. I put it because I think it's a little bit cleaner to look at. And what we're saying is basically, hey, are you pressing one of the buttons? And here's how you read if you're pressing a button. J, arm, right, dot. And then we're going to do get raw button. And what button was it? I think it was 4. I think 4 was one of the buttons. And I kind of like, I would like 4. I kind of feel like 4 should be retract the arm, and 5 should be extend the arm. Because it'd be like extend the arm, and then we're going to want to hit a button to suck something in, or extend the arm, and then we're going to hit another button to spit the cone back out. So I like having all of that on one side, and then the other side is just retract it back in. So button 4, I would like to be my close button. So that's what I'm picking first. So pick your button number that is your close button. And then we're going to do a curly brace. Do the open curly brace. It gives you the close one for free. Hit enter. Now, if you're pressing that button, then our arm power should be equal to, and we want it to go in, so that should be negative, right? So we're going to do negative, and then it was what arm underscore output power, that variable we set before. Give yourself a little semicolon because that is the end of that line. All right, so that was our first check. We checked to see if you're pressing the button to make the arm go in. Then, if that's not happening, if we're not pressing that button, now we have to check and see if you're pressing the button to make it go out. But if I do another if like this, and I just do the same line of code for the other button, what happens if you press both buttons? Actually, both of these things will run. And it's not really good to have both of these things running at the same time. So instead, what we can do is we can say, hey, if this is happening, if this button is pressed, run this code. Else, if, and then we can check the other button. So else if, and in this case, we're looking for jarm dot get raw button, and this time 5. That's my other button that I found. And then this is an open and close curly brace. So first it says, okay, is this button being pressed? Check and see if this button is being pressed. If it is, do this. Otherwise, then you can check if this button is being pressed. If the first button is being pressed, we never check the second button. We're done. We already got our answer. So no on the first button, then we check the second button. If it's being pressed, what do? Well, we set our arm power. But this time, we need to go the other direction. So instead of negative arm output power, we just do arm output power and get a semicolon at the end of that line. Then, the last thing is if neither of them are being pressed. So what we can do now is we can say else and open parentheses or open curly brace and hit enter. So first it checks this, then it checks this. If neither of those are happening, then we do whatever we put in this else case. That's the catch-all. That's the nothing else is happening, this is what we do. And what do we do in this case? Well, arm power should be equal to 0. And I think best practice is to do 0.0 because it is a double. It is a floating point number. It has decimal. But I think if you just type 0, it works fine. All right, then we've now done the logic to read the value from the buttons and to choose the right power. We have one more thing to do, and that is we actually have to call that class that we made earlier here. Where is it? Set arm motor, right? We have to call this and send the percent to the arm, or the arm power to the arm. So after we're done with all of this, double arm power, if this, else, then we need one more line of code, and that is, what do you call it? Set arm motor. And it already seems to think we want arm power, which is true. Again, if you don't have that already, just go ahead and type arm power. Boom, done. Now this arm power will get sent to that other class we made that will handle sending it to the motor. And you know what? I think it's going to work. So I am ready to click the 3 dots, build that robot code. We're going to wait. And the important thing about this, right, is we have this current limit, which means if I'm sitting here holding the button and the arm is going out and it's all the way out, and I keep holding the button down for too long, the current limit is going to limit how much power that arm motor gets, and that's going to stop it from heating up too fast and becoming a problem. If we did full power instead of 0.4, then we got to be a little bit more careful. But in general, too, right, we added the surgical tubing, And my surgical tubing is already stretched out, so we're probably going to have to add some more. You might actually want to remove the surgical tubing at the end of the day every time you're done working on the robot. Otherwise, it gets stretched out, and we'll just have to keep adding stuff to it. But the surgical tubing, right, for the most part, oh, geez, the brake mode is engaged. It's much harder to turn now. So if you try to move it when brake mode is engaged, you just got to do it kind of gently. The faster you push, the more it fights against you. The harder you fight it, the more it fights you. So you just go nice and easy. So this is all the way out. If I let go, it's mostly staying all the way out, right? And then if I fixed my surgical tubing, it would stay all the way out on its own. So the key here is after you drive the motor out and it gets to this position, you need to just let go and let it stay there. And you can tell, we definitely need to do a better job of managing our surgical tubing here. So let's give this a try. Back to the driver station. Let's get the smart dashboard up. I am going to go ahead and go back to the steering wheel icon and click Enable. That's good. Nothing crazy is happening. Now we have our drive stuff over here. I'm going to let's set our arm stuff up over here. So here's our arm power. My arm current is at 0, which is good because I'm not actually driving the arm. And my arm temperature is at 24 degrees C, which is probably the temperature of the room if I had to guess. All right. Also, I'm able to drag these around. Once you have everything where you want it, you can go to View and make it not editable so you don't accidentally drag stuff around later. All right, only one thing left to do, and that is to try pressing some buttons. So the left button, I am hoping when I press this left bumper that the arm retracts. And once it's all the way in, I can let go of the button. Now this right button should make the arm go out. Well, that's not happening. Okay, so we got it half right. The question is why. I'm going to disable this. Let's double check this button and this button. They are in order. 1, 2, 3, 0, 1, 2, 3, 4, and okay, so 0, 1, 2, 3. This should be 4, and it should be 5. Interesting. All right, so next thing to do is check the code. Did we make a mistake in the code? All right, jarm.getRaw button 5. Arm power equals arm output power. Arm power equals 0.0. Set arm power. So what button does it think I'm pushing if it doesn't think I'm pushing the right button? That's interesting. Also, we know that the fourth button made it go in, I think. Oh, you know what I think happened? This is my guess. And I probably should have known this and not led you down this road. My guess is that we might have a 0 for axes, but buttons might start at 1. Because then if you think about it, this button would be 1, 2, 3, 4, 5, and the other button would be 6. In which case, only one of the directions would have worked, with all the other code being right. So let's go ahead and try this. So instead, we're going to try making it 5 and making it 6. Now, there is a problem with this. If you figured out what the problem is, don't tell the rest of the class. We'll get there in a second. Let's build it again, and then we're going to deploy it. All right, let's go back to our two things. Now, if my hypothesis was right, we're going to enable. If I press the buttons now, the other button should do something. And it did. I heard the motor going. Let me press the first button. Remember, this is the button I want to make it retract. That totally just extended. And the button I want to make it extend is making it retract. Why? Well, again, let's disable the robot and look at the code, because that's how we can explain it. I had these cases backwards, but the values are right? Retracting is my button number 5. I want that to be negative. Extending is my button number 6. I want that to be positive. What this means is, up at the top, we need to invert that motor. So where is that? Here it is. Arm.setInverted. Turns out that should be true. All right, so switch that to true, then go ahead and hit the 3 dots. And of course, we have to build again, and then we have to deploy again, and then we're going to try it. And deploy robot code. All right. Load our other things back up. Let's enable it. Enable, and now I'm going to press the one that I want to go out, which is my right side button, and it goes out. And I'll do the left side one, and it goes in. Now, another thing to watch, right? We have current, ARM motor current here on our smart dashboard. I'm going to hold the button to make it go in. It's already in, so I'm going to be stalling the motor. And look at that. It limits it to 20 amps. And you can see, I wouldn't recommend doing this on your robot. I'm just holding the button down. You can hear it fighting. You can hear it kind of buzzing and trying to go. But I'm able to hold this for, I mean, how long has that been? 10 seconds, 15 seconds? And when I let go, the arm is still functional. It still goes out. It still goes back in. And that's because of that current limit. That current limit is basically stopping me from destroying the motor too quickly. And you can actually feel the motor. It's not warm at all thanks to that current limit. Okay, so let's make a small change. Right? You saw how fast that arm is going in and out. Maybe you want, it's a little slow. Maybe you think you can go a little bit faster. So if we go back to the code, what we're going to do is find at the very top, this is why it's so nice, we have those variables that we set up, those constants that we set up. And we have arm output power is 0.4. Let's just go 0.5. Let's go, well, yeah, maybe that, yeah, let's go 0.5. Let's go 0.5. All right, and then we're going to build. And then we are going to deploy. Oh, it was still building. All right, we're going to deploy a second time. You got to wait for the build to finish. You get a little error message down here if you try to do it too fast. All right, we are deployed. Let's go back to our driver station here. Go ahead and enable it. And now I'm going to hit the out button. It is, I don't know if you're timing it, but to me, that looks faster. It doesn't look particularly scary. I'm still kind of okay with the speed, but there is something else that I should keep in mind, and that is if I look on my driver station here on my computer screen, my voltage is 12.08 volts. So I'm doing this and my battery is dead. So if it were a fresh battery, it would move faster. So that's something to keep in mind. But I don't hate the speed. I'm going to leave mine at 0.5. Anywhere around there is kind of OK. If your arm is not moving at all, then you have to turn the power up. If your arm is moving too fast and it scares you, go ahead and turn the power down. All right, and now that's drive is done, arm is done. So let's go back to the code and get ready to do our intake. All right, well, in the code, the first thing we know we need is to go to the top of the code, scroll down a little bit, underneath public class robot extends timed robot. We have our drive motors, we have our arm motor. We do not have an intake motor yet, and that is what we're going to work on. So I'm going to go right underneath the arm motor and do a can spark max. And we'll call it intake equals new can spark max. And our device ID for this one is 6. And then for type, it's the same thing as the line above it. We could have copied the line above it and probably saved some time. It is a motor type .k brushless. And make sure we get the semicolon at the end. So now it's cool. We've now got all of the 6 speed controllers and motors on our robot in here. So that's good. Now we have some, let me see. Actually, I'm going to do a quick thing here. So this is like arm power and current limit. Then down here, I'm going to do intake. I guess it's going to be our variables, our constants for our intake, not variables because they don't change. And our intake constants, we have a bunch, right? So first, they're all going to be written the same way. So they're going to be a static final. And we're going to do, what are we going to do? We're going to do a current limit, and we're going to change the current limit. And then we're going to do a power, and we're going to have a slightly different power. And here's the idea. Let me go ahead and we'll extend this out part way. But we've got like a cube and a cone, right? And the idea is when the cone goes in and we grab the cone, we want to have 1 power and 1 current limit when we're sucking the cone in. Once the cone is in all the way, though, and we sort of let go, we want the cone to stay here. And it kind of does on its own, but it also kind of starts falling out. But what if we use a lower power on the motor and a really low current limit? We can actually pull this in and sort of just stall the motor to help hold it in place. And then we can do the same thing when the cube gets sucked in, right? That's going to go in and it hits the back. We can still try to pull it in a little bit and have a low current limit that lets us add a little bit of power to keep it from falling out, but not enough to hurt the motor. Although, to be honest, the cube seems like it's like when it goes in, it's pretty in. All right, so those are the variables, or the constants rather, that we are going to set up here. So first, let's do our int. We're going to do an intake current limit, and this is also in amps, so I'll do _a, just like we did for our ARM1 up here. And that we're going to make it equal to, I think 25 is the number that was used. And again, these numbers were from the Everybot group that tested it, and it's a good starting place, but if you have to adjust yours, you can adjust yours. All right, that is one of the things we need. Then we said we needed a another static final int. This is going to be our intake, and let's call it hold current in amps. I guess hold current limit in amps. Okay, it's just a long name. So this is that lower power mode where we just want to kind of try to hold stuff in place. We're going to make it just 5 amps. That's it. I think that motor, if it were allowed to stall on its own, would do something like 100 amps. So we're limiting it way down from what it would do when it's stalled. And then we need our powers, right? So we're going to do static final. This is going to be a double because we need decimal for it. And this is going to be intake, I guess output power. And when we are sucking in the cube or the cone, you know what? We want to go all out. So we're going to do 1.0, full power, maximum power. But after we let go of the button, after we sucked it all the way in and we let go of the button, we are going to want that value to be much less. So we'll do another static final double, and this is going to be our intake. Let's call this our hold power. And that is going to be equal to just like a small number. So it looks like we're going to start at 0.07. So it's like 7% of the motor power in order to try to hold it in place. All right, I think that's all of the intake numbers that we need. So let's work our way down until we find the robot init section, find public void robot init. And what we're doing in robot init is we are going to, again, do a intake.set inverted, and we'll find out if we need this or not. We'll start with false. Okay, and then the next line is intake.set idle mode, and we want this to be idle mode dot what is it, kbreak? Kbreak, yep. So again, when the cone is in or when the cube is in, anything that we can do to try to help hold position, we want to do. So we're going to turn the brakes on. All right. What else do we have to do? I think we're ready to actually write we're going to do the class where we actually control it. So we have our drive motors here. We have our set arm motor here. Underneath that, we're going to do another one, public void set intake motor. Sure. And then inside here, we need a double, and I think it's just, what do we need? We need just the percent, right? There's not really anything else going on here. Oh, there is another thing going on. So we're going to need the percent for the power, but then we have the amps, right? Because we change our current limit. So we're also going to have amps. Amps, there we go, I can type. And we need a open and close curly brace there, and an enter. Oh, and what did I forget? You see how amps is still red? It's still red because I forgot something. And the thing that I forgot is it is an int. we have to tell it what is the data type. All right, so we have int amps and we have double %. All right, and our control in here is basically going to be like, you know, just set those values. Intake.set. And this is the set is the speed or the percent that we want it to move. So we're going to set that to our %, which is the value we're reading in here. And then we're going to do intake dot, and it's going to be set smart current limit. And it already knows I want amps. So again, you can type amps in if it didn't figure it out, but I'm going to do a semicolon here. And for this one, we can do some more smart dashboard stuff. Let's do it. We might as well do kind of the same smart dashboard stuff we did for the ARM. So we're going to do smart dashboard dot put number, and it is going to be quote. We're going to do intake power in terms of %, and we will call this %. And then we'll do another one, smart dashboard dot put number. This one is going to be do the quotes, and we're going to type this one. And this one will be, it's going to be what? Intake motor current in amps. And it's got amps. That's cool. And then one more, dot put number. And this is going to be intake motor temperature in degrees C. And so that is not going to be amps. It's not going to be any of the variables that we have built up. That is going to be intake dot. Oh, the other one's wrong too. OK, we're going to fix both of them. Intake dot get motor temperature. And you need a semicolon. This is not amps. Amps is our limit, not what the current is, what the amount of current that the motor is presently drawing. What we need here is the same thing that we did for our ARM, which is intake dot get output current, and that will give us the amount of amps that we are currently drawing. Okay, so we just keep an eye on it. We can see if something's going wrong. We can use that to help us debug as well. All right, that looks good. I think we're done there. So now we've got to go down to Teleop periodic, and here is where we have to do the logic. So I'm going to do a couple spaces. So I kind of have the drive section, then the ARM power section, and now we are ready to do the intake section. So let's think about this. We have a few different options. Option number one is we want to intake a cone. And if we want to intake a cone, I guess we have to look at the robot. But if we want to intake a cone, we need this roller to be spinning in, and this roller, right? We need these two rollers to be spinning towards each other. So we have to be spinning in this direction to intake a cone. So that's one option, is we are intaking a cone, means we're going in this direction. We're going fast in this direction to suck it up. And then option number two is the cone is in there, and we want to be going in this direction slowly to hold the cone in place. Option number three is we want to spit the cone out really fast. Here's the good news. Spitting the cone out really fast is the same thing as sucking the cube in, right? Because we need this roller to be on the opposite side and spinning in the opposite direction. So actually, intaking a cube is the same as launching a cone or spitting out a cone, releasing a cone. And releasing a cone is the same as intaking a cube. I think I said the same thing twice. And intaking a cone is the same thing as spitting out the cube. All right. So they're opposite. So that is actually two cases, but it's the same case for both, right? So we have one case where it's in on the cone, out on the cube, and we have one case where it's out on the cube, in on the cone. And then we have two more cases, which is in on the cone and holding, and our other case is in on the cube and holding. So if the cube is already in, we need to hold on to the cube, and if the cone is already in, we need to hold on to the cone. All right, so we need to have actually 4 different choices here. Actually, kind of 5 different choices, because if we're not holding anything, then we don't really need to move at all. So we might have a case for that as well. But let's see. We're going to start with a double, and we're going to do intake power. Just like we did. We're starting basically just like we did with ARM power. We're going to calculate our intake power through this thing, and we're also going to set our intake amps as well. So guess what? We also need intake amps. And that is our current limit, our amp limit. All right. So the first thing is, like, hey, if we're pressing a button, and what button do we want to use? I don't know. Let's go back over to the driver station, and let's figure it out. Oh, I am not connected to my robot. There, I'm connected to the robot now. All right. So let's go back over to the USB thing, and let's see. What do I like? I like the top button for cone because it's sort of like the top of the gripper there. And then I'll do the bottom button for the cube. So I'm going to use Y and A on my controller. And Y is button number 4, and A is button number 1. So I'm going to be using buttons 1 and 4, but pick the 2 buttons that you want to use. All right, so down here, if, and how do we read the value of a button? Well, we've already done it. We've already done it a few times. It's jarm.getRawButton. And if you're pressing button 4, that means we want to intake a cube. All right, we're going to do the open and close curly bracket again, or curly brace. I guess it's a brace or a curly bracket. All right, and what do we do? If we want to intake a cone, then let's see. Let's do this. We're going to make a little mark here. We're going to do a little comment here. And so this is cone in or cube out. Remember, because those are the same things. So if you press this button, that is the cone coming in or the cube going out. And, well, in this case, I don't know. We're going to do intake power equals something. And, I mean, I guess it's going to just equal our intake. Remember, we made that intake output power constant. And we'll do a semicolon after that. And then we also have to do intake amps equals what? Intake current limit. Intake current limit. There it is. Okay. And there's one more thing we have to do. But right now, what I want to do is I just want to test this and see if it's going the direction that we want it to go before we do anything else crazy. So we have the if, you're pressing the button. Let's also, underneath that, let's do an else case here. And the idea is else, if you're not pressing the button or you're not doing anything else, what we're going to do is we're going to zero stuff out. So we're going to do intake power equals 0.0. And we're going to do intake, well, I mean, do we really have to zero out the intake amps? I mean, I guess we will. Why not? We'll do intake amps equals 0. So basically, if we're in this case, we're just turning everything off. And let's see if this works the way we want it to work or not first, and then we'll build the rest of our stuff. Because I don't want to do all the logic and figure out we have stuff backwards or whatever, and then have to go back and redo it. Then finally, of course, in order to be able to actually run this, we have to send it to that other bit of code we wrote, our other class that we wrote, with a set intake motor, right? Remember that section up? We just did it. Our intake motor, where we set the current limit and the percent, and we do the smart dashboard stuff, right? So we're going to call that. We're going to send stuff to that. We need to send our power, which is intake power, and our amps, which is intake amps. It already grabbed those from the previous code for me, so that's very smart of it. I don't want to change it. It should be intake power first, and then intake amps second. All right, let's test this before we dig any deeper. So I'm going to build the robot code. And as soon as it finishes, I will deploy the robot code. All right, looks good. Let's go back over to our driver station and our smart dashboard. When I enable it, go back to the steering wheel to enable. I've got more things, so now I'm going to move intake current, intake temperature, intake power down here so we can see what's going on. And they're all clustered nicely. All right. Then I guess we try pressing the button, right? So Y should be the button that makes something happen. That is fast. Wow. All right. So basically, this should be intake the cone. So what we were hoping was this would be intake the cone. It's not. This is intake the cube. Wow. It really grabs onto it there. All right. And let me push the cube out. Yeah, I don't know if the cube needs that extra holding stuff, but OK. So that's good. We learned what we needed to learn. I'm going to disable the robot. And let's go back to the code. And let's see what we're doing. So essentially what we made here, this bit of code, is actually not cone in, cube out. This bit of code is actually cube in, cone out. And that means my button is not the button I wanted to use. I want this to be button number 1. OK, and that's fine. We can switch it up that way. So now we have our first case working. Now let's do our second case. So we have if all of that, right? The next thing we want to check is we want to check else if. And what we want to check for is the other button being pressed? So now we can do, for real, jarm.get raw button. And this time, it'll be 4. OK, and at the end of this line, we're going to do an open curly brace. Press Enter. And inside of here, look, it actually knows. Look at this. It's mad about these because if we press this button, there's no value for intake power and intake amps because it knows we have to set those up. And we can take this intake power and intake amps from here, copy it, and paste it. And the amp doesn't change. The current limit doesn't change. We want to have full power, or 25 amps, up to 25 amps of power. But the intake output power should go the other direction. So let's throw a negative sign in front of it. And now we should be able to take stuff in and spit stuff out, take the other stuff in and spit it out. Let me do another on the top here. Let's do another comment. So this one should be cone in and cube out. This one is cube in and cone out. All right, let's test it again. Build. And deploy. All right, bring back up our driver station here. Up. And we are going to enable. And now I'm going to try the cone in button this time, and I'll pass a cone up and in. OK, that grabbed the cone. Now, right now, we have no protection, so you do not want to hold this button down for a long period of time. That will not be good for our motor. But cone is in. If I hit the other button, it should spit the cone out. That other button should suck the cube in. OK, well, the cube actually has to touch the rollers. And then our cone in button should spit the cube out. Perfect. I'm going to go get that cube. All right, so that's working. Let's disable. Everything is working, except when I let go of the button, we don't have any of our extra holding power features, right? The stuff that we were doing to help hold it in place. And we have a little bit of a problem, because what we have to figure out is, like, if I'm not pressing the button to suck a cube in or spit it out, or cone out, or I'm not pressing this other button to do the opposite, how do I know if I should be holding a cone or holding a cube? We have to keep track of it. So we have to make another variable that lets us keep track of what the last thing we grabbed was. Okay, and we're going to scroll up. I think a good place to put this is find Teleop init. I went too far, didn't I? There it is, Teleop init. And if we want some stuff to be available for Teleop init and for Teleop periodic, we can't really put it inside of Teleop init or Teleop periodic. So when you want it to be available to multiple of these classes, we put it before we get into the class. So what I'm going to do is go above the comment and the @override of our public void Teleop init stuff here. And what we're going to do is we're going to create a code to remember what the last thing we were holding is. So we'll do static final int. And in our code, cone, let's do capital cone, is equal to 1. So basically, if it was 1, then the last thing we were holding was a cone. Then we'll do static final int cube equals 2. And finally, our last option is static final int nothing. Nothing equals 3. So those are the 3 things that we have to remember. Either we just was sucking in a cone, in which case we want to hold the cone in place, or we were just sucking in a cube, so we want to hold the cube in place, or we haven't tried to intake anything yet, and so we're not going to do anything. All right, and then there's one more thing that we have to have here, and that is we need to create now a variable, right? These are constants. They're never changing. This is our code. Cone equals this, cube equals 2, and so on. But now we have to have a variable that actually keeps track of what was the last thing that we were holding. So on the next line here, we're going to do this time just an int, not a static, because it is going to change. And we're just going to call it a last game piece. All right, and we want to set that up so when we start in Teleop, so Teleop init is right below this, right? When we start in Teleop init, let's go below all our motor stuff. We want to make sure that we start last game piece as, and this is why we did the code here. I could type 3 and remember in my mind that 3 means nothing, but we typed all these things out just so that we could make this code easier by just typing nothing. So the last thing we were holding is nothing when we start Teleop. So if we did start with something in autonomous mode, we are going to have tried to have scored it by then. So once Teleop starts, we have nothing in our gripper, or in the intake, I guess. OK, so now we can go back down to the code that we were working on. And if we press this button, which is cube in and cone out, guess what? The last piece we intook, so find this again, it's underneath our double intake power, int intake amps. We have if we're pressing button 1. So this is cube in and cone out. And now if we're in this situation, that means the cube is the last thing we were trying to take in. So our last game piece, there we go. That's why you got a tab, because I was typing it wrong, equals cube, capital cube. So again, I'm going to hit tab to become capital cube. OK, and then in this other one, if it's cone in and cube out, guess what? Our last game piece is equal to cone. Perfect. Now we're ready to make our other cases. So we're always keeping track of what the last thing we brought in was and what we need to do. And it doesn't really matter, like if we spit out the cube, we pick up a cube and spit out the cube, it thinks we intook a cone last, but our power is going to be so small, and our current limit is going to be so small, that it doesn't matter if the thing is slowly spinning until you press another button to try to intake something. So that's just how we're going to do it. Keep it simple. All right, so if you're pressing this button, no matter what, cube in. If you're pressing this button, no matter what, cone in. Then, if we're not pressing either button, the next thing we're going to check, we're going to do another else if. And now what we're going to check is, what was the last game piece? So we're going to say, hey, is last game piece equal to something? And earlier, we used the equal sign. And the equal sign, like on all of these lines, says to take this value and put it into the variable. But in this case, we want to check the value of our last game piece, not change the value of it. And so to do that, we do equals equals. You got to do double equal sign here. All right, and if the last game piece was a, let's say, cube, then we can do something. So get your open and close curly braces here and hit enter. And what do we want to do? Well, if we were trying to intake a cube, what we can do is we can do intake. And now we're not going to use our intake output power. This is going to be our intake hold power. Hold power, not current, hold power. There it is. And we're going to set our intake hold power equal to, oh, sorry, we're going to set our power, our intake power equal to that. So intake power equals intake hold power. And a semicolon at the end. And we kind of know that when a cube is coming in, our intake power should be positive. There's no negative sign there. So down here, our intake hold power should be positive, so there's going to be no negative sign. So we know this should match our first one where the cube was coming in. Then, of course, we have to do our intake amps. And that is going to be equal to, instead of our intake current limit, that is going to be equal to our intake underscore hold current limit. And get a semicolon on. So what's going to happen now is if we pick up a cube, we intake a cube, then we stop pressing the button to intake the cube. It's all the way in. Then the next thing that's going to happen is it's going to remember that the last game piece we intook was a cube. We're going to go down here, and we are going to be spinning our roller slowly in the direction to hold the cube in with the current limit to hold the cube in. And then these intake power and intake amps still get sent to our intake motor class, where it is going to actually tell the motor to turn on with that much power and with that amp limit. So now what we have to do is this, but for the cone. So if you go after the else if last game piece equals cube, go down after the curly brace, hit enter, and we're going to do else if. And this time it's going to be last game piece. Was it equals, because we're checking it again, not setting it. Was it a cone? And if it was a cone, what should we do? Well, guess what? It's going to be the same two lines of code. Our intake power is going to be equal to our intake, intake hold power. But this time it has to be negative, right? Because our cone direction here is negative intake power. So down here, our cone direction should still be negative hold power. Don't forget your semicolon at the end of that line. Our intake amps is going to be equal to our intake hold current limit. Like, you don't even have to put the underscores in, just kind of type most of the letters and it finds it for you. All right. So that is good, right? So now, if it was a cube, we're going to be spinning slowly in the right direction to hold cubes with the low current limit. If it was a cone, we're going to be spinning in the right direction to hold the cone with the correct current limit. Yeah, let's test this. I think we're good. I think we finished everything. Let's build the robot code, and then we'll see if we can get it to work. And 3 dots and deploy robot code. Build failed. All right, if you get this build failed, we just have to kind of look up and see what the issues were. Are you connected to the robot and is it on? Okay, so my failed build here is because I can't see the robot anymore. First thing to check if you can't see the robot is, are you connected to the robot? I'm going to open my wireless networks, and look at that, I am not connected to the robot. I'm going to connect to the robot, and then it's going to work. That is the number one thing that will go wrong, especially like if you switch over to the internet to like look something up, download something. Got to remember to switch it back. Also, I think what happened was we tried to charge the battery up. We took a short break. We tried to charge the battery up. So when I turned the robot back on, I never came back here and reconnected. All right, but now though, 3 dots, deploy robot code. Much better. It found the robot, and it is deploying. All right, and I'll go ahead and close that Reolog again. Let's look at these things. Good. I'm going to enable the robot, and let's test it. So we'll come back down here in front of the robot again. So now, I think with the last one, right, let's intake the cone. And when I let go, you can kind of see it's not falling out as much as it was before. Last time when I let go, it sort of sank down about, halfway before it caught it. And I can also tell it's working because I don't know if you can hear this, but this motor is kind of screaming because the motor is like going a little bit and then hitting the current limit and stopping. And that's good because the motor's not heating up. All right, let's spit that one out. And now you can see, after I spit it out, it thinks you're intaking the cube. So you can actually see these rollers are moving to suck in a cube, or would be moving to hold the cube in. Let's go ahead and do the cone. Just tap the cone. Like now it's going up this direction to hold the cone in there until you hit the current limit. And here's what's cool. Like normally I would say you shouldn't be grabbing the stuff on your robot when it's moving, but look what happens if my hand gets stuck here. it stops moving because we hit the current limit. That current limit is so low that you can actually go ahead and put your hand in and sort of feel what the pulling force is. But if I try to turn this back, there is some resistance, right? All right, let's go ahead and intake a cube. And that is holding in there and not moving. Now that we've intaked the cube, what I can do is I can hit the button to extend out. I'm going to give myself a little bit more room, though, for safety. So let's hit the button to extend out. And then we can dump the cube out. We can bring it back in. And I guess we have to just go out a little bit. Let's try picking up the cone. All right, and then for the cone 2, we can extend all the way out. Let's extend in. It's nice and safe. It's not hitting anything. Extend out, and let's dump the cube off. All right, and pack the robot back up. All right, I'm going to go ahead and hit disable. Okay, so that is it. We have, I think, finished our Teleop program. We have full control of the robot, right? We can drive. We can extend the arm out and retract it in. We can intake cones, we can intake cubes, we can spit out cones and cubes. So yeah, we are done with the program. But before we go, a couple things that I want to point out, just in case you're having trouble. The first thing is you can change the power output and the current limit for mostly just the power output for the arm and the intake if you need to. Remember, if the arm is moving too fast or too slow, you can make this number a little bigger to go faster. You can make it a little smaller to go slower. Down here on the intake, I don't think you really ever want to turn the intake output power down from 1, because when you're intaking game pieces, you want to go fast. You want to grab them as fast as you possibly can. But you might want to increase the hold power a little bit. If you suck a cube in and it's slowly falling out on you, you could try bumping this 0.07 up to 0.1 or something like that. You could turn that current limit up a little bit, but not a lot. So maybe you could go to 6. The problem with the current limit is the higher you put it, the more power is still going to the motor. And if the motor can't turn, that power has to get turned into something. It gets turned into heat, and heat is bad for motors. Too much heat will burn out a motor. So you want to be as sparing as possible on turning that up if you have to. Also, if any of your motors are going backwards, remember we have the is inverted for all the drive motors. We have is inverted for the arm. We have is inverted for the intake. So if everything is working opposite of the way that you wanted, that is where you would change that. And if you're running into any trouble with any of the other pieces, my first suggestion is go back and watch that section again. Make sure that you don't have any of the red squiggly lines popping up. And remember, everything is case sensitive, so you got to really watch your syntax. But that is it. We have successfully completed teleoperated mode. We'll be back in another video to do autonomous. We might do bumpers first. I'm not sure yet. We're figuring that out. But either way, we will see you in the next video. But as always, before we go, special thanks to Argosy and Everybot.